Hey guys, we are recording this video session.
Yeah, I can see it.
Okay, good to know. Good to know. Now I'm going to project my desktop. And here it goes, sharing my screen. I'm also sharing you my whiteboard, which is coming up. And I'm also opening up my browser, which is right here. And I would like to point out that we have been recording these sessions and I'm storing them in the DevOps section. If you go scroll down a little bit, you will find in the DevOps section is right here, this section called Spring 2018. This is for DevOps. It's a different one. And in there, we have these two videos. This is the one from the first day in which we covered these things. I don't know if you had a chance to watch these at all or not. I know you were busy. You had meetings offsite and other things. Some of you were on vacation. Some of you were traveling. And so I will do a recap. Don't worry about it. What I want to do is, this section, we began discussing about what is DevOps, and there's the reference to a book that we discussed, where the thing came from. That's what we primarily discussed that day. And we also did a little exercise with using Chef as a tool. And the next day, on the 16th, which was the day before yesterday, like this day, I covered some basics about some of the concepts to get these tools, like we discussed. 3 tools we are going to focus on, right? Chef is one of them. Ansible is another one. Docker is another one. We'll focus on these 3 tools and understand how these tools help enable complete end-to-end automation. There are more tools, by the way. These tools will keep on evolving. People in the open source community will keep on developing new tools, and we will incorporate them as and when we feel that they're appropriate for our use case. So yes, these tools are useful, but I would like you to focus on the concept, not so much on the tool, because the tools will come and go. Tools you can pick anytime. It's not a big deal to just pick a tool and start working with it. Not a complex thing at all. What is more important to understand is the ultimate goal. What we're really trying to accomplish is to automate every single thing we can. That's what we're really trying to do. And the thing that you cannot automate, what do you do with that? You have people to deal with. That's where you put people in charge and let them do things that are not automatic, cannot automate certain things. And we understand that. And that's where people come into play. So things that can be automated are, the simple way to think about this thing, which I think you already understand and know this, but I'm just going to recap a little bit because I know you were out, you were away. So the recap goes like this. We'll not spend too much time on recap, just short, very, very short. But I think it is good. By the way, let me ask you, did you get a chance to watch the videos at all or not yet?
Yes, I did.
Okay, good. So were they any useful? The DevOps videos specifically?
Yes.
Okay, good to know. So quick, 2 to 3 minute recap. I'm just making sure that we are on the same page from what we are trying to accomplish. From a top level perspective, our goal is to make this person, let's call him our customer. That customer is the ultimate person. We want to make them happy. We want to give them value. And when we give value, we typically get something in return. That's business, right? That's the whole idea. We want to make sure that this value that we provide to customer. So this is our company, whatever we do in our company. In that company, we will have people of all types, various types. Some of our developers, test people, designers, architects, other types of people like sales, marketing, service, and there are more. People who are, I will say, overhead. I call them overhead, but they're bosses, managers, supervisors, those kind of people. They're also, in the company. They all collectively do something productive. At least we assume that they are productive. And so they produce value, right? And the key thing to remember is that this value creation has to be driven from a pull perspective. Let the customer decide what they want. Let them pull what they need. Don't push. Do not push whatever you have, whatever product you make. The moment you start pushing, it's not the right direction. You would rather instead get driven by customer feedback. And in classic control systems, control systems as a method of study, or as a subject of study that you probably know, there is this idea of feedback loop. So you have a input that you apply, and there is an output that you receive, and you can drive that output, whether it is correctly going exactly how you want it or not, by receiving a feedback loop. And in that feedback cycle, you typically apply the feedback as a input coming straight from the output, and this is what usually produces the result that you want to produce. That's the classic concept in control system. This is a negative feedback that you want to incorporate to adjust what exactly you're driving in your process of building stuff. And here is your company producing value, producing a result that you give out to the customer, and you want to receive feedback. You want to let the customer decide what they want. You want to give it to them, and in the process you want to do this very, very dynamically. You want to do this in the most agile fashion. And I gave you some examples. Like, for example, if the customer decided that I would like to see purple color, and so what I did was, in an example, I was able to change the color of this site, like this ink that you have, red color ink, orange color ink. I was able to change this to purple color ink because you wanted it. I mean, I'm just fictitiously saying that you wanted it. So you said, make it purple. And I was able to make a change in the entire repository. We have a Git repo. And in that repo, I was able to change the color and just do a Git push, because you requested the color to be purple. So I took that feedback, incorporated it into the repository, and pushed. When I pushed, everything else basically flew. It flowed correctly all the way through end-to-end deployment, and you saw the result, where you saw that this person is able to see the color purple because they wanted it, they pulled it, they required it, they requested it. And so we were able to deliver it to them based on whatever they're asking for. And we were able to do this with minimal effort, like literally on my part, zero effort, except I was able to edit something in my repository. And in there, I was able to do a git commit and git add, git commit, git push. Then I'm done. Everything else is handled completely automatically. That is not magic. It is not, it has to be built together to make such a thing happen for every single project. Because what we're really trying to accomplish is automate end to end and be driven by customer demand. Because when you are able to accomplish that, you are actually be able to produce value for the customer, because you are giving them what they want as opposed to giving them that they may not, which is where the value comes from, right? That's the goal. To accomplish this goal, we use a variety of tools. And one of those tools that we started using was the Chef tool. We'll also cover Ansible. We'll also cover a bunch of other tools. Although the program currently is focused on these three tools, we'll also include other tools like Terraform, for example. And in the subsequent section, we'll have a very, very recent product called Kubernetes, which is a very well-known, you may have heard of it, I think. Did you hear about this thing called Kubernetes as a very well-known product? It is an open source product. It is on GitHub. Are you familiar with the name Kubernetes as such?
Yes.
I'm aware of it. Yeah.
Okay, so it is also being included in, I think the person, Philip Tho, is working on in your company. If you know him, this guy is working on, he's a technical architect in your company focused on Kubernetes. So that's what he's doing. You should contact him. He is a container service manager, technical architect, Docker, and Kubernetes. That's what he's doing in your company. So you know him. You can find out about him. He's a Cloud Genius graduate from a long time ago, and he is focused primarily on that idea. So which is a nice set of capabilities your company is also focused on. You should interact with him and find out what he's doing, which is going to be useful, because we have included that section big time in everything Cloud Genius runs is in Kubernetes containers. In containers, using containers runs in a Kubernetes cluster. That's how I would say. And we also use this, another product, another tool, to enable the scenario, the end-to-end scenario. So we will use these toolings, these items are probably going to be in the architecture section. Because we don't have enough time to cover everything in DevOps, we will put these things in the architecture segment, because that's a new thing that we have included in our bootcamp. These are relatively newer tools and techniques, especially this one that we have recently incorporated. So we will include them in the architecture segment. But right now, let us focus here. And that's what we are discussing. So in Chef, as you know, it comes in two flavors. One of them is the solo version of Chef, which we started discussing the last time. And the other flavor of Chef is a Chef client that requires a Chef server together. And then these things together operate on some infrastructure. This product we started using was Chef Solo. We began using it and we played it on a target machine. The first target machine that we chose was our virtual machine, the Cloud Genius workstation. That workstation that you know already have, that was the target that we chose. Like, you want Chef to run, okay, run it right here. That was the first example. Then we started using the same tool and we started understanding what that Chef product is, which has a variety of components. Like you probably saw this idea of a kitchen in a video. You may have seen that kitchen. The kitchen comprises of cookbooks, and it has some nodes. It has roles. It has some other things like I'm forgetting. So I'm going to pull up that workstation and find out what it has. Okay, not this workstation, but the other one. Okay, it's opening up. New workstation powering up. Saying okay to this and start. You will see the kitchen that I'm going to start, that you probably have already, or if not, you will see it in my workstation. And what these things are essentially folders in this big folder. That's where we will work on in a context of Chef Solo or in the context of Chef Client, Chef Server. They all operate in a folder, and that folder is called kitchen. In there, we will have subfolders containing cookbooks. Cookbooks are stored collection of recipes. Recipes do things for us. Nodes are these targets. Like, you want to target Chef to run on these nodes or run it on those other nodes. So you can have multiple nodes in your cloud and multiple clouds. It doesn't even matter whether it's a cloud or not. It can be a machine in your garage. It can be your grandfather's laptop. It doesn't even matter. Wherever it runs, it can run anywhere you like. Most people run it in the cloud. And so you can run it in multiple clouds, including grandparents' laptop or, whatever. It doesn't matter. Any operating system that has somewhere to run, where Chef will run. So Windows, Linux, Mac, all of these, they will run Chef, no problem. And that becomes this machine M1, M2, like these guys become nodes like that. That's where Chef runs. So Chef needs to run right here and here. And if you have more machines, it runs right there. That's what the execution model is. Now you want to run Chef client, it also runs on those target machines like that. It will run on these M1, M2, M3 machines. Those machines are called nodes. You can put these nodes together and call them a role. For example, these two machines can become your web role, and that can be your database role. So you can create roles. We discussed that the last time. There's a video for that from the second day for DevOps. And then there are more folders like that. You will see that I'm going to open up that folder that I was working on the last time. It is called the My Cloud folder. And there you will see that I have a kitchen ready already. We created this kitchen from scratch. And that folder is opening up right now in Atom. The folder looks like containing a cookbook folder, which has a bunch of cookbooks. This cookbook collection came down from a source. We did not write these books, but we gathered them. We gather them from the supermarket. And again, this is all a recap going rapidly. So it may sound rapid because we have already covered it in the second day. But from the supermarket, you download books. And you download books manually, or you can use a tool to get these books for you. The tool is called Burks. Yeah, that's the name. Burks for Burk Shelf. That's the exact spelling. It is based on this word called, and you will laugh at it. You probably know it. What's it called? Oh my God. Yeah, that's the word. Yeah, this is the meme, Armageddon. And this is where the Burke shelf is based on. It's called Burke shelf. So that's this tool, Burke shelf, which is used to get books from the supermarket. What is supermarket? It is a website where books are stored. People contribute. There are books available, about 3,600 of them. Almost all the books that you need are probably available here. So we'll use these books. We'll put them in our cookbooks folder right there. And that's what this thing is showing you right now. Bunch of books downloaded by the Burke shelf tool. Then there is environment, which is where you can classify environments, such as you can put this cloud. I have certain machines in the production environment. So I have these machines in the production environment. I have this environment where I am testing. It's my testing environment. I have more machines here. And I have these machines that I would like to actually be in a development zone. So I have those machines in the dev environment. So I can classify these machines in different segments. They are called environments. That's how you can basically label them differently so that they behave differently. And you can, of course, customize and have a machine in the development environment have a custom setting for something. For example, a timeout value. I'm just picking up an example. Timeout value can be large, say 300 seconds, as opposed to a small 30 seconds. In the production, you want to keep a small timeout. For development purposes, you may want to have a large timeout. You can adjust these parameters depending on the environment you have in mind. And that's what we are looking at, the environment folder. Similarly, the nodes section, where you will see that you will have to have a file corresponding to the node in question. So for example, I created a node in the cloud and I labeled it this name. I gave it a DNS friendly name, web1.cloudgenie.us.json. It's a JSON file that I was able to create in this cloud. You can create in any cloud. It can be even your grandparents' laptop. It doesn't matter. As long as the laptop is accessible on the internet, Chef will run. So I'm logging in to some cloud. I will provide my token identification and create a machine there. And in that machine, you will see that I am going to pick just a droplet. And that droplet, I will say that give me Ubuntu machine and give me the cheapest possible machine size. And there I select it in San Francisco and I select my key pair. And I'm going to give it a name. This name can be anything you like, doesn't matter. And I'm going to create the machine. Now this machine needs to be mapped to a DNS friendly name. This friendly name has to be a fully qualified domain name. Something like, you have a .top level domain, whatever that may be, .net, .com, whatever the TLD you have. Then you have your domain name here. You can map it to anything here or even here. So basically, as long as it is an FQDN, you need to map that as an A record pointing to the IP address I have from the cloud. Or it can be your grandparents' laptop, doesn't matter. IP address needs to match the domain you're looking at. And so in my example, I'm using this web1.cloudgenie.us is my name I chose. So that's the fully qualified domain name I'm going to select. And therefore, the node name that I need to have in the nodes folder needs to have a file that is named like this, but with a .json extension. That is critical. So that's what I'm going to grab from here, this randomly named machine. You can actually change the name here. This name is irrelevant. I don't bother about this name. That's not important. What is important is that you grab the IP address from here and then take it to your DNS of record. So I have my DNS of record in Cloudflare. That's where I manage my DNS names. So I'm going to log in. And in there, I'll find my domain, which is this domain. There I will find my DNS. And then I look for my web1 entry. I find that I have this entry called web1 from the last time. The IP address was different. This time I have an IP address of this value, different value. So I save it. And now I will go check whether this new value is correctly mapping to this IP address or not. I will go do a dig query. Go back here, go to the terminal, run, dig. And what do I find? web1.cloudgenie.us. What do it needs to get me the A record matching to the current machine. And it does match. So this match 69,227. Does it match here? Okay, come on, here. Yes, it does. So that's the machine that I want to talk about. That's the machine I want to actually run Chef on. That is my node. So that becomes my node, like right here. And this is the node I'm going to interact with. In that node, I'm going to provide a entry like that. Because this is the DNA injection I'm really trying to put into the machine. In that DNA, what I'm saying is, here, run a recipe. For example, I would like to run a recipe called nginx : default. Make that machine become an nginx server when the machine grows up. So I'm doing an DNA injection to that machine. Which one? This machine, whatever that machine is. This one, which is the DNS name that I have assigned to be, and I'm going to label it like this so that it's easier to remember. But again, this name is irrelevant. This is the host name. This is not the fully qualified DNS name. If you want to get to the fully qualified DNS name, you should be able to ping it like this. So ping web1 dot. That's the FQDN. Or I just ping incorrectly. Similarly, you can connect to it like SSH root at web1 dot. Like that. It should connect successfully. And there is a verification failure because I have a known host file that matches the previous attempt from day before yesterday. So I'm going to remove that known host file like that. And that should solve the known host issue. And that is gone. Now I'm going to connect, and it will let me connect, and I succeeded. I'm going to come out of that machine. I can come back in and find out that the host name, this ASDF, is irrelevant. The host name is a value stored in the machine locally, and that is this value. It has absolutely no meaning to us. What we need to really do is make sure that our DNS value, which is this name, is exactly what we have in mind. So that should be the name of the node file. You go look at the nodes folder. That's what you will find is this web1.cloudgenie.us.json is the way that machine knows to connect to. So now if you want to connect to that machine using Chef, you need to construct a command to run Chef on that target machine. What you will see now is I'm going to open Sublime and find out what do we have. And so what I'm going to do now is say run Chef on the target machine. For that to happen, I would like to tell you that you can invoke in the cloud. You have multiple machines here, and all that. So you want to run Chef on these machines, you need to have entry for each of these in your nodes folder. Nodes / and then the machine FQDN .json. For every machine like that, you need to have an entry, and then it will be able to understand what you are doing. Now you want to run Chef in these machines, you can totally run Chef on those machines. But the way to run Chef on those target machines is that on your laptop, you need to run a different tool. The tool is called Knife. It's a kitchen tool. It's all about cooking in Chef. So Knife you run on your laptop, and you tell that you want to run Chef on that machine. So you have to provide this FQDN.json reference, and it will know what to do. So there are 4 things you can do with Knife tool. One of them was the first one we began with, initializing our kitchen. It initializes this folder structure that you look at, right? This folder, this whole folder was created using the init command. You will say Knife solo init and then dot. That initializes the kitchen. So that's a very important step. You do it like one time for a project. Next one, there are 3 things you can do. You can say Knife solo prepare, Knife solo cook. This prepare step basically installs Chef on the node, the target devices that you have, these machines out in the cloud. That's where chef will get installed when you say knife solo, prepare that machine, FQDN. It will install chef on that node. Then next one, again, knife solo, cook that machine, FQDN. It will run chef on that machine. That's what will happen. And you will see this happening, by the way. I'll execute shortly. So these two commands, cook and prepare and cook, are collectively operable like that. You want to basically run Bootstrap. If you run Bootstrap with a knife solo execution, type properly, knife, come on, write properly, knife solo Bootstrap. So Bootstrap is basically a combination of this prepare plus cook, those two things together. It's a shortcut. So you can run Bootstrap to just install chef and run chef together in one shot. And so that is what you can potentially do like this. So you go here and say in the command line, I want to now not connect to the machine directly, but instead use the chef tooling to make things happen. What I really want to happen is have the machine grow up to become an Nginx web server. So this recipe I'm including and the default recipe in the Nginx cookbook. The cookbooks are already here, but what if they're not here? What if I have this folder deleted like that and it's gone? And now I don't have a cookbooks folder. So I'll create an empty folder like, come on, new folder and cookbooks. So the cookbook folder is empty, but that is okay because it will know to get this Nginx cookbook because we have another tool included here called Burk Shelf. And that Burk Shelf uses a file called Burk's file. You heard me say this Burk Shelf tool already once, but the key idea behind this Burk's tool is similar to the bundle tool. The bundle tool, what it does, it gets you gems. It downloads them and installs them and all that good stuff. And it looks at a file called gem file. So this Burk's tool will get you books, like cookbooks. And it will download them for you and place them in the right spot. And it will look at a file called Burk's file. That's what Burk's file, this file is. It tells you where to get the books from, the supermarket. And then which book? This book. Which version? That version. That's how you define it. And that's what you have defined it in the Burk's file. So you don't have to have books right in the cookbooks folder because it will get the books if they're missing. And that's what will happen when we invoke chef on the remote computer, which requires us to run knife locally. As you know, you have to run knife on a local machine, which will remotely install chef and run chef. We want to do that exactly that. What we want to do is, I want to say, come here and say knife solo, and then prepare that machine I have in mind, that machine. I have the one which is, what is that machine called? It is called root at web1 dot something like that. That's what I want to prepare. And so that's what it will do. It will prepare the machine, meaning it will install chef. So this is the chef way of talking about install is prepare. Prepare with a single P, not the double P's there. So we want to remove the P. And similarly, you want to have the next step is to actually run chef. When you want to run chef, you will say cook. So this is like the chef way of naming everything for use in what I would say the context of cooking, the cookbooks and recipe and knife and things like that. So that's what we're really discussing. And so back in here, what I want to do is we run these two commands. And what these two will do is this one installs chef. And this one will run chef. Run chef where? On the remote machine. That's what installation and running will happen all on the remote computer, like that one that we had just created on some cloud. It may be your grandparents' laptop. Who cares? Doesn't matter. It can be anything. So let's go run that exercise. What I'm going to do is I have that machine already pinging, correctly connecting. So I'm going to just run this. And you remember one thing, very important thing, which is that you want to prefix everything with a bundle exec. And that is a very, very important thing for you to do. And if you do not do this, you will have issues. The reason is, if you want to run something with a particular version of a gem that I have here called Chef, and I want to run 12, 10, 24, then I need to make sure that I am invoking that particular version of Chef. If I want to run that version, I will like to get its version number, and you will get the correct version if you execute it with the bundle exec prefix. So I got the correct version that I'm expecting in my gem file. You can see in line number 4 in the gem file. However, if you skip this thing and just say chef client and get the version, you will get the wrong one. You don't want the wrong one. You will get the wrong version, and you don't want it. It is going to get you the wrong version, like that. It's going to get the latest version available on your computer at that point in time. If you look at my gems installed, you will find that the list of gems I have for Chef are 3. There are 3 different versions of Chef installed. This is the latest one, but what I really wanted was this one. And that's what will run, provided you prefix with a bundle exec. If you forget that, you will have trouble. You will also not be able to maintain discipline in your company. You want to have everybody on the team operate with the same set of versions that you have agreed upon. And therefore, this prefix is a super important thing to remember. Well, having said that, I should also use the same prefix, bundle exec. And then I'll say knife solo, prepare that remote machine I have in the cloud, which is this machine that I'm talking about, web1.cloudgenie.us. I just prepared it. And I know I have a corresponding JSON file. So I don't need to type the JSON here, but I need to type the FQDN. And based on the FQDN, it will look up the appropriate node to deal with. In that node, there is this run list defined, which is to get that machine functioning like a Nginx web server. And that's what you will see happen once I go to that machine and say in this name, if I try to open that on a web browser, nothing happens because the machine is not a web server right now. It is just enough operating system, JEOS. We just booted it and we did nothing with it. We connected to it just to make sure, but then we did not type any command in there. We are not manually touching the machines. We are not, so what I will say, there is a word for it. Let me just bring up that word. And it's important to remember this. So you create a machine here. It is just enough operating system, right? And I connected to it SSH. And that's fine. But the first thing I should do after I connect to the machine in a SSH is exit. Do not touch it by hand, or rather, I should say manually. Do not manually touch it. The moment a person touches the machine by doing something like running VI, running some command, modifying some parameter, doing something, anything as simple as modifying some simple file, you are making the machine dirty. This is how you should think. Not that you are deliberately doing it, making it dirty, but that's what you just did. The reason you don't want to do this manually, by like a person going in and modifying some settings in a machine, is a bad idea. The reason it is bad is because it makes dirty. But what does the dirty really mean? That's what I want to explain. If you know it, please tell me that you already know so I can skip. But you will find it strange when I say this, that you create a new machine and in the cloud and you say you can connect using SSH, but I'm saying don't touch it. Don't mess with it. In real life, you should not. So then how do you program that machine? How do you make it your machine? How do you make it grow up to become something like Nginx server, for example? You do this every single thing you want to do with the machine in a automated fashion. You are doing any changes to the machine in a disciplined fashion, in an automated fashion, in a controlled fashion, using some kind of a repository in a Git repo. And you are writing code to make things happen onto this machine or 100 other machines. but you are not touching those machines by hand. Like, absolutely not. Everything you want to do thing inside a repository and do this programmatically. Programmatically is how you change your infrastructure. You're not touching it by hand. That's a fundamental principle you should think and remember for yourself. Like, it is very different from what you may have done in the past. But by doing this, what you're really trying to accomplish is that anybody in your team will already know that nobody touched the machine. It was just pristine as it began, and all that was done to the machine was this repository that we know and we have agreed upon that this is what we are going to do to the machine. And so we exactly know what the current state of that machine is, because we know that this Git repository actually programmatically ran some code on that target machine, and we are dealing with it. So we exactly know what that state of that machine is. It was just enough operating system to begin with, and now it has grown up to become a giraffe. I'm just kidding. Not giraffe, but Nginx server. And so that's Nginx. No, something wrong. Nginx. Yeah, Nginx server. So you exactly know, and you want to change the Nginx configuration. That's fine. Just change it in your Git repository, in your kitchen. Make the changes. Anything you want to change to the computers out there in the cloud, you go back to your repository, make the change right here, change the state, change your desired state, and then run your magic. And then the actual state will become matching with desired state. That's what you want to drive towards, so that everybody on the team exactly knows what is the state of your infrastructure at any given point in time. Because you know that nobody in your entire company, in your entire organization, has actually touched, and literally touch. Don't touch it. Don't bother. Don't mess with it. Keep it nice and clean. Manage it. Manage your desired state through automation. And you're not going there yourself, not touching it. By a physical person, like a human being, going and modifying something into a collection of machines, what happens is, if this person in your team makes a change to this machine in the cloud, then the other person may not have any idea about what they did, unless they are doing this change in a Git repo in a kitchen and are writing down exactly what will change, and they're changing the desired state, and then they're they are going to run run a knife, prepare a knife cook. Then they know exactly what is going to happen, because now this person can just read this code and find out what changed. So they will know, and they will agree upon as to what the changes was. So it's easier to manage. Well, the word that I was going to talk about is this word called entropy. This is a word from thermodynamics, which basically means that you are creating chaos. If you touch things by hand, like go to the machine SSH and try to modify a setting, no, you're creating chaos. And you want order. And by order, I mean discipline. And discipline comes from the fact that you are not doing it by hand, because you're doing it through automation. So that orderly method of managing your infrastructure can be accomplished, provided you don't mess with the machines directly. But anytime you want to make a change, go back to your Git repository, understand what needs to change, make the change in the Git repository, and play. Play meaning prepare, cook, or in Ansible, the word is actually play. There is in Ansible, you don't have cook book. Like in Chef, you will have cook book. In Ansible, there are playbooks, and you write your playbook, or you use an existing playbook and you play them. In Chef, you cook them, or you prepare and cook them, or you bootstrap them. In other tools, there are other phrases used. Like, for example, the Microsoft Desired State Configuration Management, they have a concept called run book, and you run them. The same idea across the board. Multiple tools, they all operate similarly. They have different ways. This is like a Ruby based language, Ruby language based. This is Python language based. And this is Microsoft's own DSC method of describing stuff. And other tools uses other languages, other frameworks, but they all conceptually operate very, very similarly. The whole idea is to bring discipline to a teamwork in a collaborative fashion, so that you are managing the state of your cloud, multiple machines, multiple locations, multiple clouds, including your data center in your company, your grandparents' laptop, things of that nature. Anything you deal with, that you know exactly what the state of your infrastructure is at any point in time, because all of that is documented right here in the kitchen. And that's what we will do. We will change the state of our computer from this nothing, just enough OS, to a state in which it becomes a Nginx server, because we are going to give them a run list. The run list is to run the default recipe in the Nginx cookbook. So that's the recipe, that's the node definition I have. Saving it, closing it. That definition is stored in the nodes folder. And I am going to now make sure that my cookbooks are empty, but doesn't matter, because our bugs file, bugs tool will get the book for us, and we are now ready to run it. So here it goes. Bundle exec as a prefix. Knife solo, prepare the machine, meaning install Chef. You can then come back and say cook the machine, meaning you run Chef. And when you run Chef, you will see that this Nginx cookbook gets installed and it gets played over there. But you can shortcut this and say bootstrap, and it will do both prepare and cook, one after the other in one shot. This one line, it does it all. I'm going to run it right now. Here it goes. So you will see that it is first going to install Chef on that machine out there in the cloud, and then it will run Chef on the target machine. I am running locally. I'm running knife solo bootstrap that machine, please. And so it's bootstrapping that machine by first preparing it. And the preparation involves installing Chef. You will notice that the version of Chef it installed is exactly what I had in mind in my gem file. It's not installing the random version of Chef that it thinks is right, but it is getting the one version that I called out, this version in my gem file. I require it. That's what's getting installed. So once that thing gets installed, it is going to run Chef. So this installation, I think, finished. So we'll now go read. So I think the Chef run has already started, but it will tell you that it installed Chef somewhere here. Where did it say? Thank you for installing Chef. So now it's going to run Chef. So this is the cook step started right there. Before that, it was the prepare step. The bootstrap action that I just did is a combination action. It involves prepare and cook, one after the other. And so now you see that the thing is doing its thing, and it has actually done a bunch of things, including running Nginx server on that remote computer. Right here on this web1.cloudgenie.us, we now have a web server running Nginx with no page. So we say 404 not found, because there is no page to show, but it is running Nginx. That's what we wanted. That's what you got. That's what we have here. Now, back here, what I want to now do is extend the idea. What I want to now actually do is back to the kitchen.
Naresh?
Yes.
So if I have to install a web server on 15 machines, and do I have to specify each node on your command line, or you can an easy way to read from my notes folder?
There is always an easy way. So I'll tell you what that would be. The exercises we are doing is actually a very small one. We are focusing on just one machine, and you don't have to specify these things on a machine by machine, like 100 machines on a command line. That's obnoxious. That's not how we would do it. What you would do is actually call out these nodes that you have all over the place in this cloud and this cloud, and you have multiple machines everywhere. These are basically your target nodes. So you need to specify them in a variety of fashion. You can specify them in the best way to deal with actually would be in a Chef server, where you just have these entries created in the Chef server itself. And then Chef runs by itself. You don't even have to manually invoke knife command. The way we are doing right now is just beginning to use Chef. The actual final implementation of a full-fledged Chef deployment will be a situation where you don't even need to run knife. What you really do is you set the whole thing up and you go on vacation to Hawaii. That's what really is the goal. The goal is to let you go, to do whatever you like, as opposed to manually running knife. That's not the idea. The idea is to remove yourself from the picture so that the whole thing runs by itself. That's what we will get to. What we will see is this Chef client and Chef server combination, where you have Chef client running on these machines right here and right here and here and like that, here. They will run by itself on a cron job, typically every 30 minutes. It's up to you, up to your company, what you decide, what your projects, you decide how frequently, how periodically you want Chef to run on these target machines everywhere, wherever, in multiple clouds, multiple locations, whatever that is. And Chef will run by itself. It will then interact with Chef server and find out, hey, what do I need to be when I grow up? And I would like to understand that. So Chef server will tell you, grow up to become Nginx web server. And by the way, you grow up to become a database server. And you go do up something like Hadoop server. God knows whatever you come up with. You come up with your own product set, your application set. And you have to decide the DNA, the node definition, like here is my DNA for this machine. So you specify that and you call it out and you write these things inside somewhere in a centralized location. That location will be storing information about DNA for these machines as you grow up. And then you have to, from your laptop, you have to send the DNA instruction, or rather your kitchen, for example, will contain everything. You will have to upload your kitchen to the Chef server. You have to send cookbooks there, you have to send node definitions there, roles, and this and that, they all go to the Chef server. And then you do this on your laptop. And you will send your entire kitchen to the Chef server. And then you go to Hawaii and you enjoy. Because what you have done is you have managed a setup in which these machines run Chef by itself. They will interface with Chef server and get whatever their purpose in life, the goal, purpose in life. My purpose in life was to become an Apache web server. So I understand that. I will understand this detail purpose from the Chef server will tell me what do I need to grow up to become, and then Chef will run right here and it will become that thing, whatever the purpose is, the desired state. It will take care of it by itself. And if you come back from Hawaii and you want to change the state, you will do exactly that in your repository, in your kitchen. And then you say, upload the kitchen, boom, to the Chef server. And then you upload your instructions to the Chef server. And this time you go to Sedona on vacation again, because you have uploaded your new desire and you give it to the Chef server, say, hey, store it. Next time Chef will run, say, here, and you want to now run Hadoop, but maybe run Spark. Well, that's a new desire. So you have Spark running there. And then it becomes your Spark server. And you are still vacationing in Sedona, because you're not typing manually, you're not doing nothing. All you really do is you write down your desire in this kitchen. as long as you're using Chef. If you're using Ansible, you write down your desires in your playbooks. If you're using some other product, you write down your whatever desired outcome is in form of a folder structure like this in some location in a Git repository, and you deal with that particular tool's capabilities as to how does it disseminate information to the target machines. The ultimate usage really depends on the tool, but the goal is basically to go to Hawaii. I mean, you can pick your destination of choice, but that's the goal, is to not manually type these stupid things like knife, do what? Why do I have to type this? No, I'm not going to type these knife commands, but I did. I mean, I have to type these to tell you, but ultimately you don't have to type these things. I hope that was clear. Okay, so now we have, was that clear?
So the Chef server is a public open server.
Yeah, it is open source. It is open source available right there. So you can say GitHub Chef server, it's open source right there. Oh, so no, that's not the product. This is the product, open source. Yeah, you can build your own Chef server. We have an exercise for that. Somewhere here down below you will find it. We'll do these things. So we have exercises for that. Where is the Chef server exercise? Come on. So there's exercise set here. We are renting a Chef server right there. That's exercise. Then we have to have our own Chef server, so we can do our own Chef server for our organization. And it is open source, so you can build it yourself. So you have choices. There are multiple exercises available here. It's up to you as to what you want to do. And I'll do all of these things for you live, all exercises. You can pick and choose what you like and appropriately focus your attention to the idea that is most interesting to you. I will do all of these things depending on your interest. There is more content available than we have time available. So I may have to skip some of these things. But the exercises are written down for you. They are available in this website right here. Right here. They are there. You can actually click and follow along. You can just follow these instructions written down step by step. You can just make this happen on your own without me involved, because I give you instructions like do this, do that, and do this and do that. And it'll happen. It'll work. But I will do this for you live, and I'll adjust this according to what you have in mind. That's what we do in the bootcamp, right? Live. So that's the Chef server. It is open source. You can also rent it. By the way, in your company, you have a license to the Chef server already. So you have licensed a commercial version of Chef from the ops code company, the Chef company, which is a Seattle company. You have probably an in-house hosted solution, which is licensed to you as a commercial product also. You can use the open source version as well as the commercial version, your choice. Okay, let's see further what we can do with this, this kitchen that we have, like here. In that kitchen, we have this cookbooks already available now. They just popped up here because Burkshelf put it right there. This tool called Burks File brought this cookbook and it put right there. In this location, we have the Nginx cookbook. And then alongside, there are other cookbooks also that it brought down because they are dependent cookbooks. So you now have all these books here. Now we briefly discussed environments. We also discussed nodes. We have discussed roles in the last time. We made sure that we mentioned this site cookbooks folder as a folder different from this folder, because this folder you can just delete like that and get rid of it. And it is managed by Burks File because it is getting these books from the supermarket for you, and that's where they store the books. So you can again create a new empty folder like this and call it cookbooks folder, and it's there for you empty. But that's where you don't have to deal with what you create, your cookbooks. You want to store it in a different location. Like here is the location I suggest. Site cookbooks, which is the name that I have here, which is what you want to create your books and store them separate from this collection. This collection is managed by Burkshelf. You want to manage your own cookbooks yourself. So your creations go here. You create them, you store them right there, and you include them in the folder in the kitchen. You have to also make sure that this folder, site cookbooks, gets priority precedence. Like this entry is before this entry. So this site cookbooks will get priority precedence in the cookbook path, which means if you create a cookbook right here, and there is a folder here containing the same book name, remember the name. If you have two cookbooks, one here and another here, the one in site cookbooks will get precedence. That's how we have written it like this. This phrase is before this phrase. That's a key thing to remember in the knife configuration of your .chef hidden folder. That's a hidden folder, by the way, and this file is a critically important file. It also contains a lot of secret information. We'll add more secrets there, and so it needs to be protected. You don't want to let this knife RB go to public. You have to keep it private, and you can accomplish that by not sharing it. Just remember that. We'll also go into some modalities as to how do you actually remember to not share it by automation. And that simple idea is this file called gitignore. You want to ignore the .chef folder like that, and specifically the knife RB. You want to hide it from Git visibility. By doing that, you're ignoring this particular file from getting into the Git repository. Now you can see that if you now create a Git repository in the current kitchen, like here, do I have Git right here? No, I don't. So can I initialize Git right here? Yes. Now if I say git add dot, what do I see? Git status. I see that I have the .gitignore file, bugs file, log file, data bags, environments, nodes, all these. But you will notice that one thing is missing here, and that thing that is missing is the .chef folder itself has been ignored by the gitignore file. That's how you protect your private information, which is supposed to be remaining secret. So you add a entry in the .gitignore file like that, and therefore it is not going to be added to the Git repository. So even if you share your Git repository, it is not going to go along to other people in a push or a pull or a operation like that. So that's how you protect that particular private file, which is going to contain your secrets. With that, I will now discuss data bags. Last time we discussed a simple data bag operation to create a new bag here called MySQL JSON. This data bag idea that we have here is basically a folder, and most of these files are plain text. Almost all these files are plain text files. So the thing I want to talk about data bag is actually one of the most interesting aspects of this chef tooling. And if you look at the folder called data_bags, in that folder, this is a plural word. So you can have multiple bags. So here is bag, some bag. Let's say bag number 1. Here is another bag, bag number 2, or bag number 37, whatever name, some random. It doesn't even have to be a number. It can be any name, any string. In this bag, you can have items. Item 1, item 2, like that. That's the structure of organization. All of these are files. This is a folder, like that. And so in that, this is also a folder. So the idea is you store your information, like secrets, for example, secrets for your applications or your infrastructure secrets, that you will store them in these items, like here. And you put them in a bag, and you put all of these bags in a bags folder. And that's what you're looking at right here. Come on, where is it? Here, data bags. There is a bag called pass. We'll create another bag right now. What I will do is maybe get rid of this. So I'll say get rid of this bag like that and delete. And you will now go to this location where I have the instructions written down for us to play with. And I will go and find out where it is. And come on, Safari. And I think I accidentally closed it. So I'll open it up again. go to the right location where I have this written down for the exercise I want to do, and that involves data bags. So I will go straight to that item, and then we'll create a bag. So this bag creation business, there is this tool that we are using is Chef Solo, and it doesn't support bags by itself. Like this tool that we have, Chef Solo, in the gem file, it doesn't support bag by itself. So we added another gem that adds the bag handling capability. So this is a new entry I just added, the very last exercise I did the other day. This is a new gem that I add that brings the bag handling capability to Knife Solo. So now with that added, we need bundle update again so that this new capability gets installed. That's what we are doing here. And then we are going to create a new, I'll describe what it is. So this command goes like this. What we are really trying to accomplish is to use the bundle exec prefix. We are saying Knife Solo, data bag, create a bag. This is a bag name, and this is an item name. So we're going to create a bag called pass with an item called MySQL. That's what I'm really trying to accomplish in this command. So it is bundle exec Knife Solo data bag create pass MySQL, and that you can run right here. And for that to succeed, I needed to clean up my data bag folder as it was to begin with, empty. And now I will create a new bag. Let's go like that. Bundle exec, Knife Solo, data bag, create a bag called pass with an item for MySQL. Now you will see that this thing is kind of, what I call an overkill. I think it's an overkill. And I'll tell you what I'm talking about pretty simply, in that, you want to create a simple plain text file, and what are you doing? You're typing all this thing for no reason. Why? Like, why are we typing so much? Oh my God, Knife Solo data bag create pass MySQL. Why so confusing? All you want to do is create a folder and a file. Why can't you do it manually? You can. Nothing prevents you from doing. But what you saw when I ran this, a new editor pops up. This editor is giving me a place to type stuff. I'm going to provide it a secret. I'm going to say my password is going to be super secret. And I'm going to save this. And I saved it. So I save, and then I close this window, and then a new item gets created. Let me not close it before right now. Hold on, keep it on the side. I'll go look at the atom editor. You will find that there is a folder called pass already created because the bag is getting created, but the item is not yet there. As soon as I save this window, save and close, a new item gets created. The item is called MySQL JSON. It contains the ID and the super secret I saved. Now, why can't I create this manually? Yes, you can. Nothing prevents you from doing that. But then why am I talking about this complex step? The reason is, when you're dealing with bags or other data bags in the Chef server scenario, you cannot edit the Chef data bag entries in an atom editor like this. Cannot do that. The only way to access a data bag in the remote location without Solo in the Chef server scenario is this command. With a create action, or you can have an edit action similar to this phrase. You can say edit, and it will edit the bag stored away from you in a remote Chef server. Edit, just like that. You will open up the same editor. You can say my super secret password is not so secret, and save it and close it, and then close the window. And you can see that the bag has successfully been edited, and you can see that the item shows you not so secret. Now you can do these actions remotely on a Chef server just like this. That is the reason why they want to bring compatibility between Chef Solo and Chef server setups, and that's why the command is seemingly so convoluted. Now, having done this part, you will like to know that this not so secret phrase actually is a secret. So I want to keep it encrypted because the Chef server may or may not be in my control directly. So I don't want people to know my secret. So I want to actually encrypt encrypt my secret. So how do I encrypt my secret? This bag and this item, I want this item to be encrypted, for which I need some kind of a encryption key. I need to create one myself, and then I use the key to encrypt the secret, and then I store it in the bag, and then the bag can stay in local computer or can stay in the chef server, whatever the case may be. So that's what I will be doing now, is to create an encryption key and then use that key to encrypt before I create a new item in a bag and a new bag. So I'll now create, we just created a bag called pass, and in that we had an item called MySQL. We stored my username, password, whatever. So that's one bag. I'll, forget that bag. We'll create another one. We create a new bag with a different name and contains an encrypted item. That's what I want to do now. So I will go here and say next, and that's where we have encrypted bag to keep the secrets secret. For that I need to generate a secret. So what I will do now is begin generating some random number, like a really large random number, pretty much like this. Pops up, 512 character long, base 64 encoded random number generated through OpenSSL library. And I have it right here. This is base 64 encoded, and it's a random string. What I want to do now is look at this string, and you find that after this F letter, there is a new line. And after this I letter, there's a new line. And this E, there's a new line. I don't want any new lines. I want all these things in one string, straight line, one line, without any new line characters. I can enable that by using the trim command. I can pipe it through trim and remove any new line characters or carriage return characters, pretty much like this. What I'm doing is piping it through this command, trim, delete the return character and the new line character. By doing that way, what I'm getting is a string of all these 512 characters generated as a random string showing up in one line, one single line, without a new line, without a carriage return. So that's going to be my secret. I'm going to store this value. It is a random number, by the way. Every time I run it, I get a new value. And that value, I want to store it somewhere in a location where I can use it repeatedly. And I want to make it consistently usable in repeat runs. I don't want to generate a new secret every time. I want to create a key that I will use for a project, and I will keep that key safe. So this encryption key that I have, which I created like this, I want to actually redirect it to a file that I will be storing in the .chef folder, because that's where I keep my encryption secrets. And I'll call it the encrypted data bag secret. That's the name I want to use. So here it goes. Oops. So I'll do it again. I'll just type the whole thing again. I think I typed it incorrectly, so I copy it again, and right there it goes. So what I'm doing is generating a random number, trimming the new lines, and then redirecting the output to a folder called .chef and a file inside there. The file will be called encrypted data bag secret. Boom, it goes. It created a new secret right there. By the way, this secret, as you can see, is one line. There's only line number 1 there. There is no second line. There is no new line. There is no carriage return, and it is a long secret. That's what I want to use as my encryption key. So now I have this encryption key in place. I would like to make use of this to generate an encrypted data bag. Let's go see how we do that. Back here, what I want to now do is use the same long way of doing things, the boring way of creating a data bag, just like this, except this time the bag is called passwords as opposed to pass. And the item is still called MySQL. The unique difference this time actually is this segment, is to use a secret file reference to the actual encryption key that I have in mind. So this encryption key, the encryption key I have created and I saved it right there in the .chef folder. I want to use that encryption key and use it to generate an encrypted secret. So you will see in my data bags folder, I have a old bag here called pass. So we'll leave it alone. But apart from that, I will now have another bag that will be called passwords. And then it will have an item called MySQL. And this will be storing my secret for MySQL password. And I'm going to use this -- secret file reference to the .chef / encrypted data bag secret item that I have, the encryption secret, this one. I will be using that secret to create a bag which is encrypted. Let's see what it does for us. So I'm going to run it. It opens up the editor like right now. And it gives you the same exact thing that you will expect to see the last time, except this time it will be encrypted. So while I am editing, I'm able to see it because I'm doing it. So I'm going to save my password. And my password is going to be very, very complex. And I'm going to save it. It's a very complex password. Nobody can tell. 1, 2, 3. It's a secret, right? Don't tell anybody. So we're going to save it and close the window. As you can see on the other side in the Atom editor, there is a folder called passwords already created, but it doesn't have anything yet. I'm going to save this and close it. And as soon as I close, you will see a new item called MySQL pop up in the passwords folder, because that's what we had. Passwords folder and MySQL item. So closing that window now like that, and you will see that it created a new bag item called MySQL in the passwords bag right here. And there is an item in there, and let's go see it like there. And what do you see? Where is my 1, 2, 3? You see that? This is encrypted bag, or rather encrypted item in the bag. It is actually showing you 1, 2, 3, but you cannot see it. You cannot figure out that it is actually 1, 2, 3 because it is encrypted data. Somewhere in here between this and this is the encrypted data stored using my encryption key that preserves the secrecy of my passphrase or my password, which is 1, 2, 3. You know that. So I want to see what is my password. The only way to see now and decipher is to actually view, or rather, I'll say in here, you use this command to create the password, right? So I'm going to say edit the password. That's one way to see it. You will run the edit command. It will invoke this other editor, and it will show you the editor, will show you the exact item that was being encrypted and stored in this file here, in this file in the Atom editor. I'm going to open the editor again. It will open up and show me 1, 2, 3. I'm going to make this 4, 5, 6 or some rather random number, doesn't matter, some random sequence, and save it. And when I close it, you will see that the encryption key, the encrypted version will change. So remember this LQT, whatever that thing is, it will change. All of these characteristics will change because it is now storing 4, 5, 6, blah, 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 that blah, 4, 5, 6, blah. That's what is saving. So I'm going to save it, save and close. And you will notice in the Atom editor, the encrypted phrase, which is highlighted right here, will change as soon as I save this window. Right now, as you notice, LQT right there. Close. And it became different. Now it is different, but you really cannot decrypt it unless you have the encryption secret. And this is how you generate a encrypted data bag item, which only you can decipher. Questions are welcome. Another way to actually deal with this seeing, examining, which is you want to examine, not edit, but just see. So to see this, instead of edit, you can just say show. And you want to show the password, you can just show it. It should show you the password, 456 blah. That way you can read it. And this is an outcome of a command that is using the encryption secret to decipher and show you the item called MySQL stored in the passwords bag. Any questions on this idea? Because this can be a little bit clumsy. There are too many moving parts here. So if there are questions, please ask them, because we'll use this, in a subsequent real exercise. I'm just building towards it right now.
So where is the secrecy here? Because anybody can type, okay, this command, they will get the password.
Yeah, they need to have this file.
So file is, we are hiding from .chef. Nobody has access to that, or?
Correct. We did that already here, right? So we'll add this new item there. We'll hide this one also, because this is our encryption secret. Don't want to give it to anybody.
Yeah.
Right?
Yeah.
So that's how you protect your, using this file. You're not sharing it. You're giving it only to your team members, and not with public, not with anybody. And just team members will know what the secret is. They need to know this password, so they will have it. Your machines might need to know the password in the database for a connection string, so the machines will have access to this detail. But other people, no. Chef server, no. Chef server will have no idea what your encryption secret is. So Chef server will store the detail like this. Chef server will have no idea whether this means 456 or 123 or God knows what. It will not know, because it will store this detail. Okay, further. I will just quickly checking our notes here. Okay, good. So we proceed further. What I want to do next is to set up a node. Now we are changing our desire. Remember, our desire initially was to bring up this machine and make it become a Nginx server right there, right? That was the desire to begin with. But I'm going to change the desire on you, and I'm going to write that down in a very black and white fashion. To set up a node that has MySQL server ready with root password. So as you know, MySQL server setup is actually trivially simple. You can go here to the machine that I have there, connect, and you can set up a server, and this server has your Nginx running already, right? You can see it running, but I want to install and make this machine a database server. So what you should not do is do it manually, right? But I'm going to show you how not to do things. So here's the bad way of doing things. You can say, make this a machine running database server, MySQL. You can say sudo apt install MySQL server. So it will make a MySQL server out of the machine. But this is exactly how you should not do things, right? Don't touch it manually. And I just touched it. Now we have a problem because other team members have no idea what I did. That is not what you want to accomplish. So you know that setting up a database server requires you to create this, handle this screen. This screen, it is expecting you to give a root password for the database user. I'm going to give it some root password here, like say 123, for example, and say okay, and then I repeat my password 123, and this is a manual operation. It is also cumbersome to deal with like this. And imagine if you have hundreds of machines like that. You don't want to do it manually, so you don't deal with it manually. But I did to show you how you should not do. And setting up a server is easy, right? You saw that it's happening, and it will finish off, and very quickly we should be able to connect to the server, use it like a database server. And now I will actually connect and show you that it works. So here is my server ready. I will now connect to the MySQL server with a username as root, and my password is 123. And boom, I connected to the MySQL database right there. So I'm connected, I'm able to use it. But this is what you should not do by hand, right? So since I made that machine dirty, I'm going to kill it like right now. Here we go. I am going to destroy the machine since I touched it. Like it's now dirty because I touched it. So that machine needs to die. Here we go. Destroy the machine because I touched it. Simply, that's a valid reason to kill a machine. Somebody touched it. It's ugly now. I cannot touch it anymore. So the only thing that should touch the machine or modify or manipulate machine is your code running in automation. So go droplets, and I don't have any droplet. So I want to now, this desire that I have right here, set up a node that has MySQL server ready with a root password. That's the desire. So the desired outcome is a node is ready, accessible online via SSH. So we'll just finish that desire right now, right? Create a droplet, and we will call it and by the way, I think there is some instructions here on the instructions are, next step is to use this base, Ubuntu 14.04 as a base. That's the desired outcome. So that is something to remember. Use 14.04 as the base for an exercise that makes it simpler to understand. Nothing more than that. Just to make it easy for us to understand what we are dealing with. That's the reason I'm making it simpler for you, is to use this operating system. I'm going to begin with not 16, but remember 14.04, 64-bit. That's the one you choose. And you can select 1 GB machine, the cheapest one that you have, and add some store location like San Francisco, and select your workstation key and call this one web2 rather dot something. You can call it whatever you like. And give it a fully qualified DNS name. This is not the place to give an FQDN. This is just a host name, but create. So create machine is getting created. I'm waiting for the IP address. I got it. So I copy it. And then I go to my DNS control panel, Cloudflare. And in that Cloudflare, I will log in. And then go to my DNS zone and look for web2. If there is an entry like that, web2, no record found. So I'll say, okay, create a web2 record. And with this IP address, make it a 2-minute timeout and add the record. Record added. Now, back here. This IP address should be the one that gets pinged when this machine, by the way, is dead. So I need to kill the terminal. So killing it. Come on, terminal, you should die. And so terminal gets killed. And then I start a new one, go to the My Cloud folder, and then attempt a connection just to, actually, we should not even bother attempting. I'm not connecting at all because I told you to not touch the machine manually, right? So I'm not touching it. You can just ping from outside. Web2. Just pinging it. See it's pinging the right machine IP address, 65 to 52. Let's go compare it. 65 to 52 is the right one. Okay, good. Now that machine is ready. What I want to now do is accessible by SSH. I'm going to assume that because it's going to work because I created it and I know it works. So we'll skip that part. Not testing for SSH because I don't want to even bother touching the machine manually. Having said, my desire is to have the machine become a MySQL server and is installed and running and ready with root password that I select. That's what I want to do. So I am then going to run Chef. Before I run Chef, of course, I need to install Chef, which means when running Chef means I need to run the cook command, and then installing Chef requires me to prepare the machine, which requires me to run the prepare command. So we will begin with a cookbook. Of course, the cookbook we need is a MySQL cookbook. So we'll go to our kitchen, and in the kitchen, we will change our collection of books we need. We don't need Nginx, so I can get rid of that. And instead I'll say, give me this book. Sorry, not this book, but the book called MySQL. That's the book I want. So I'll get that book and save it. So now when Burke Shelf kicks in, it will automatically get this book into my cookbooks folder. That's my book list that I need in the Burke's file. So I'm adding that, and I can run Burke's update. And you can run that, but it's optional right now, actually. You can run update, bundle exec, update Burke Shelf, which will bring the book down, and you will see that the MySQL book will come down, and it will get stored in a central location. So the MySQL book came down, and it's available to your machine. It's not in the folder yet, but it will appear in the right time when you need it. So that book will show up in this location when you need it. When you run a cook, when you cook, it shows up. Next, what I want to do is to define the DNA of my machine. So I'm going to define it like this. I'm going to say in my machine here, this is the Web1 machine, by the way. I'm not touching it. I'm creating a new node. And that node, I'm saving this content and saving it as, in the nodes folder, I'm going to save it as web2 .json. So the fully qualified DNS name .json as a separate file for the second machine we are dealing with. And in there, we have a run list. The run list is to install the server recipe, not the default one, the server recipe for MySQL cookbook. And then it will become a MySQL server. That's the idea behind the server recipe in the MySQL cookbook. But by the way, before you run this run list, I'm going to provide some attributes for you. And the attributes that I want to select is for MySQL, the server root password should be 123. That's my desire. So I'm specifying this override attribute right in the node definition itself here, web2, in which I'm saying MySQL root password should be 123. And there is a replication password and there's a Debian password. They're not these values, we are not using it. So not using these values, but it's okay, you can leave them there. What we want to focus on is the root password value, which is what we really wanted to have the desire. The desire is to have your root password selected. So you're selecting that in the attribute right there. We assign the attribute value and then invoke the run list. And when we invoke the run list on the target machine, web2, it will become whatever you define in this DNA, or rather the desire, your desire. So you have specified your desire in that kitchen, in that file, and you're now ready to invoke chef. So we will invoke chef. How do you do that? Simply like this, one line. You can run it like this, or you can also run it like this, since we have a fully qualified name reference. If you have an FQDN, it becomes simpler like this. If you don't have an FQDN in your DNS control panel, you want to still use the IP address, you can use the IP address like that. But then you have to pass on a reference with a -n option to call out the name that you intend to use. But this is kind of clumsy. The easier and more appropriate method is to just add a DNS entry like there. That's the more appropriate method to use. And when you are using this instruction to connect to the machine, you want to bootstrap it. This idea of bootstrap is very simple. It has two parts to it, the prepare part and the cook part. The prepare part is install chef. Cook part is run chef. This action will do both of them, one after the other. So we want to run the line number 8. I'm going to grab this and run it like that. Back here in the command line, in the terminal, where we are in our kitchen. And we're going to run it. and say, you connect to that machine, the Web 2, which is a just enough OS, brand new machine. I'm not touched it. I'm going to prepare and cook that machine using knife. Running here will invoke Chef over there and go. So it doesn't have Chef installed over the remote machine, so it is going to install Chef. And then once Chef gets installed, it is going to run Chef according to this desire that you have expressed in your kitchen. So we are doing it, and it will do exactly what we told you. So the Chef version is also matching your gem file, and now Chef is running. You see that this MySQL cookbook is rendered and then uploading the kitchen. The kitchen is going to that machine over there, the whole kitchen. And then in that machine, it will do whatever it says, which is run sudo chef solo rb DNA JSON, the same thing that you saw in a first exercise. Same thing, but this time it is actually installing MySQL server with a root password that you select, 123, right there. This value popped up. So now your Chef, your machine Web 2 will have MySQL server. Now it is finished. So now we can explore the machine, see what it did. Let's go to the machine, SSH, Web 2. Go there and find out, what do we have? We have, okay, let's see, make it a little big full screen. And there we will check what we have running, a database server already. I think so, it is running. Okay, now let us see if we can connect to the MySQL server using the root plugin name and using the password, which is 123, and test, and boom, it works. Exit, and you log out. That's what it takes to accomplish a desire that you write down black and white in a kitchen like this. And you express your desire and you make things happen. Later on, you can go and muck with the machine like I did. That's why I'm able to connect to my database. I'm using it. But then, you are not mucking with the machine directly like I am doing here. And I'm like trying to connect to the machine manually. That's not how you use production machines. So you don't want to go there, but it's okay to go there. I mean, nothing wrong with it. Just realize that now it is dirty because you entered, you touched the machine. So it's dirty. It's a dirty machine. The only way that you want to engage with the machine is through automation. So now with this, I'll take a short break and we'll begin with more complex exercises. This was a very simple one. We'll begin with, let's see what we have in the agenda. This one. Next, what do we have next? Okay, we verified it worked. Fine. Next. Okay, we are going to, we are beginning the journey for what I would say is the most difficult exercise in our bootcamp. The most. This is it. Which means if you are going to do one exercise in Chef, this is it. No, you may not have done the previous ones, that's okay. But if you're doing one exercise, do this one, because this will take you through every single thing about Chef, like absolutely everything end to end. You run one command at the end and it will deploy a full-fledged service complete with an application, every single piece involved. It exposes every little feature that Chef has to offer. And you will have a fully functional application running in a cloud machine. And you can expand it further. And that step is also written down here. So if you're doing one exercise, this exercise typically takes me 2 full days if I'm doing it, like explaining everything step by step. And that can be daunting. Yes, it is. Let's see. No, hold on. It's not that exercise, is it? No, not that exercise. The next one is the one daunting exercise. This is simpler. Hold on. Let me just quickly see. The next one is the most complex one. Okay, hold on. There's a cheat sheet, and after that, the big exercise comes up. After the cheat sheet, and that is this exercise: complete application and dependencies. That's the most complex exercise. It's not coming. It's not today yet. Thank goodness. So yeah, so we'll do a simpler exercise with Chef Server, and then we'll begin with this full-fledged exercise, which actually is about, like I said before, deploy a complete application and its stack of dependencies in the cloud using Chef. One line does it all kind of a scenario. It is the most complex exercise, but thankfully it is not today. So we'll prepare you for dealing with Chef Server to understand how is it different from Chef Solo, and we'll get ourselves ready for it. I think the shorter exercise before that as a precursor is a good starter. But what I would suggest is, if you find time tomorrow, you should already watch this video walkthrough, which is, by the way, it's a 2-hour long. And this does the whole exercise, the most difficult exercise that I mentioned, in one sitting. And I'm explaining this exercise as a walkthrough, but I am not specifically in this session. I did not answer any questions. So I was just going nonstop, back to back, 2 hours, 13 minutes, 16 seconds. That's the marathon Chef video walkthrough that I have recorded here. It is, I do explain, but I'm not stopping to do a question answer session. That's why it is kind of short, and short as in only 2 hours and 13 minutes. But we'll go through it. I think we should be able to finish, given what I have seen is we should be able to finish it in the next time when we run it, the complex exercise that I'm mentioning, which begins at this point where the video walkthrough is. You should read ahead and maybe listen to this video ahead of time. But for today, after the break, I will begin using Chef Server, and we will begin from this point onwards, which is to use a ready-made Chef Server. In other words, renting a Chef Server. So we can rent for $0 a Chef Server, or we can build ourselves because it is open source. So we'll do that also as a separate exercise. That's a simple exercise, simpler compared to the one we are going to do next time. This renting is a simple option because you pay nothing and you get to rent a Chef Server. That's easy to do. You need to go to this website where you can get access to a Chef Server for free. And free comes at a limitation. So the limitation is that you can manage only 5 nodes at a time, manage.chef.io. That location is where you can rent a Chef Server for yourself. It is free for use. The limitation is that you can manage only 5 nodes, which is enough for us. We are just doing a couple, maybe 2, 3, depending on, maybe 5. Maybe we cross the limit. Crossing the limit is not a hard limit, not a hard limit. You can actually cross. I'm not sure. Not sure if you can cross the limit or not. I don't know. We'll find out whether the limit is hard or not. But bottom line is, it is free. So use it. You'll learn from using this, and then you build your own, which is a simple exercise subsequently. You can build, just another one-liner, run it. It will give you a ready-made Chef Server on your machines, in your cloud, in your location. Doesn't matter which location. As long as you follow the instruction, you build up a machine, run that one command, it will build a Chef Server, and we will use Chef to build a Chef Server. And then use that Chef Server with other Chef exercises. You can do that. That's the build part, open source, your own thing. And that doesn't have no limitations. Oh, sorry, I should say no. It has limitations by the hardware that you put. So how big hardware can you put? That will decide the limitations. But typically, that tens of thousands of machines comfortably for a $20 droplet. A $20 machine like a 4 GB RAM, enough. It will handle like tens of thousands of machines, no problem. So $20 per month is the estimated price that you would pay for a decent sized Chef Server. But later on, let's begin here. So bottom line, in the break, which is going to start now, I would like you to create a new login onto this website, manage.chef.io. So a creation of login meaning get started. And then you start your free trial. It is free, no credit card needed, just sign up and agree. And by the way, if you somehow manage to cross the limit, somebody might call you and say, hey, you're crossing a limit. And so you tell them that you're studying, that you're in the Cloud Genius boot camp, and that you're learning Chef. They will stop bothering you. They're good people. They're not going to haunt you down and why are you using this more than the limit and all that. They just go away because they know that you're learning, so they're not going to haunt you. But that's the rental part. So open an account here in the break. We'll start the break right now, and we'll start using this Chef thing right now. So I'm going to start the break timer. Timer for 7 minutes. And here it goes.
Hey, Nilesh.
Yes, hi.
Hi. Quick question. It's asking me for if I want to create a new organization.
Yes, I should clarify. In the process of creating this chef server for yourself, it will ask you to create a new organization. An organization can be a project name, team name, company name, whatever you like. And you can just create something that is unique to you. So like your home, family name, or some last name, something like that. So pick a random name. But remember what you chose. That's the most important thing, is to remember.
Okay.
It'll be different from a username. It'll be an organization name. So the projects in Chef will be associated with the organization that you will create, and you need to remember what is your org name.
Okay.
For example, I'm going to log in here, and I will show you my organization name. By the way, I have several of them. So I have multiple organizations. And so currently I am using the classroom organization, and I have a bunch of others. But I'm just using the classroom organization. In there, you will find that I have a bunch of other things. I'm going to clean up what I see to match what you see on your side when you log in. So I'm deleting these things right now.
Okay, so it's just like a project name, right?
Yeah, exactly. So
So
company
I can call it Cloud Genius as well.
You may not, because it may be taken. It may be taken.
Oh, so it can only be, okay, so
Unique.
unique. Okay. Sorry, I missed that part.
No worries. So what we intend to do now is to begin using this new tool that we now access to. This thing is a chef server. Now, this company that makes it, or rather is renting you, they'd like to call it something different. They do not call it chef server. They call it chef manage. That's why the name of the website is manage.chef.io. This is like marketing, branding. I don't care about it. All I want you to know is that they call it chef manage, or they may call it whatever they like, but it is chef server. Just remember that. And so I will now begin with what you would see pretty much. That's the simulation of experience I would like to get to. So I'm going to go to a screen that you should see when you first log in. And I think you should see something like this. Something like this. You should see that. It is a place where it will give you a starter kit. That place you should be able to get to by going to this location. The location will be something like this. So manage.chef.io/organizations/ the name of your organization that you chose /getting started. That's the name you want to get to. That's the URL you want to get to. For example, I'm going to open the Cloud Genius Workstation Firefox browser. And by the way, remember to do this in Firefox inside the workstation to make it easy on you. So what I'm suggesting you to do is to open the Firefox browser inside the virtual machine, just to make things easy on you. And there you type this link, which is, for me, it is manage.chef.io/organizations/ name of the organization. My organization name is Classroom, followed by getting_started. That's the URL I would like you to visit inside your workstation where you log in. And then you should land on the page that I just am going to land pretty soon. And that page is a place which gets us a starting point. That's where I want to get to. The starting point is right here.
Can you paste that URL to the Slack?
Yes, I will paste it in the chat. And what I will do actually is give you a link to the starting point of this exercise. So that exercise has the URL already. I'm going to paste that link in Slack so you have it. Slack is starting up. And I'm going to grab that link and go to the Spring Bootcamp starting point right there. And that's where the beginning of this exercise is. And you will find that this exercise requires us to use the manage.chef.io website where you have a login. Now that you have a login, please switch to the workstation. And in there, in the Cloud DNF workstation, open Firefox browser, log into that site, and then visit this unique URL, which includes your organization name. Like I have the name right here. That is where you should head to. That's a beginning point. And there I want to actually download a starter kit. So you need to hit that button that says download starter kit. And I'm going to hit that button. And since I have done it multiple times, it is asking me to answer this question. Are you sure? And the are you sure question basically is that it is going to invalidate all previously issued keys. And there comes another key pair. This key pair that we will be dealing with is a key pair that will allow us to manage the Chef server. It is a unique key pair that is in between your laptop and your Chef server, your Chef project that you're dealing with, just between the Chef server and you. That's the key pair. It's unique to the Chef server. They're creating a new key pair for you. They're giving it to you, and you need to use it. That is what they are changing on me. And they're asking me, are you sure? And I said, fine. So I said, proceed. As soon as I say proceed, it downloads a bunch of things for me. That bunch is called with a variety of names. Like here, they call it the starter kit. Now here in the download file, they call it chef-starter.zip. Fine. I'll open the folder. And there, I see that I have an Nginx cookbook downloaded previously. I don't need it, so I'm going to delete it. I have this chef-starter.zip file. I need that. I just downloaded it, right? So I'm going to expand it and say extract here. And when I extract here, I see that a new name pops up. This name is called another different name, chef-repo. Fine. But what are we really dealing with is the kitchen, right? I call it kitchen. These guys call it chef repo. You can call it whatever you like. It doesn't matter. But that's the folder I want. That's a folder that they gave me in the zip file. I downloaded it from here in the download starter kit. Variety of names, but all of them are talking about a same thing. Thing that we are dealing with is this folder that I wanted. And I wanted this folder directly in the workstation. That is the reason why I wanted you to open this browser. And now that you have the kit downloaded, we don't need this browser anymore. You can close it. Quit. All I really wanted is that zip download, because this contains unique key pair for your account with your Chef server setup. And so it is already prepared for us. We are going to use this to begin with. I want this folder to be in the right location. And to me, the right location is the home location. So I need to move that to the home location, or like right there. So now I have my home location containing this new folder called chef-repo. I also want to go back to my downloads location where I have the starter.zip file. I need to delete that file because it is clutter. I already expanded it. It is sitting in my home location. The thing is called chef repo, and that's what I have now. So I'll go back to my command line, come out of this location, and then list, and I find that this chef-repo folder is available. I will go there. And this is my new kitchen. It is already connected with my Chef server. Let's go examine what it contains. I'll open it up in Atom Editor and find out what it gives me. Here's what, this is the old one, so I'm going to close it out. The older one, I'm going to close it, close, and my cloud folder can be removed from project. So it's gone. This is the new project that I just opened up. It contains my kitchen. Let's see what it contains. It has a README file that I don't need, so I'm going to delete it. The first thing you should not do is read the README, so I'm deleting it. I don't like to use that README, so I'm deleting it. I like to do it my way. So of course you are free to do your way. So there's no such thing as a right way or a wrong way. It is your way or the highway. That's how it goes. Right? You decide what is right for you and you do it your way. That's how open source works. It's your way. Nobody else's. Everybody else is, their way. So you do it your way. I'm doing it my way. And I'm going to examine what it contains. There is a folder called, .chef. It has a PEM file. This is the private key. This file, you should not show it to anybody because it is supposed to be private. This is a private key pair. It is a private key that corresponds to your Chef server. Actually, this one corresponds to my Chef server. So I should not have shown it to you, but that's okay. In practice, you should not be showing it to anybody. This is your private key with the Chef server issued. So you use this key only for interaction with Chef server, nothing else. That key is referenced in this file here. You can see it, line number 7. The client key is that file, the private key. You will also see that your username pops up in line number 6. That's your username. Line number 8 has a reference to your organization name right there. And then there are some other characteristics that we'll go through in detail. This is your knife RB configuration. The configuration is already prepared for you and your names will pop up here and here and your organization name pops up here because this is customized for you. That's your knife RB. Excuse me. So now with this knife RB, what I would like to now do is look at the other folders we have. So there is a folder called cookbooks, which has a cookbook already for us called starter. And then we also have a roles folder. In that folder, we have a role. So that's what we have currently. Now with this understood, we would like to understand what to do with this particular cookbook and what's the point of this entire kitchen. This point of this kitchen is like hello world application. Think of it like that. Very, very simply, hello world. At the end of this particular cookbook run, what you will see is that it says, welcome to Chef, and then your name. That's all it will say. Welcome to Chef, comma, your name. And it knows your name because you have a login there, right? In the Chef server. So that's the idea behind this particular cookbook. It's a very, very simple thing to play this particular cookbook, and you will follow along in this write-up. Now, in here, you will see that there is this, okay, hold on, let me see some, there are some custom things that we're doing here. So what I'm doing is I am actually going to prepare ourselves to operate on the Amazon cloud in this example, apparently. So that is something that I want you to be aware of, which means you need to open up Amazon console panel, Amazon control panel, which is called Amazon console. And then go to your cloud location. I have this location that I choose. You can choose any location you like. So I'm going to go to this login first and then provide my token and then go to the appropriate region, like Northern California, for example, is a good one. There I have a VPC, and I think I have 2 VPCs there. So there are 2 VPCs. You can use the default VPC for this exercise. So I would suggest that you use that one, default one. In that default VPC, you will find that you need to look at your security groups. And you want to make sure that your default security group, which is this one, for the default VPC, should allow you access inbound rules for port number 22. So you should double check that piece, 22 Is it allowed for you to come in? It is allowed for me to come in. You can see that this is my IP address. You can check, double check, and find out that that IP address actually belongs to me. You can go through this curl.api.org to get my IP address, and not API 5, IP 5. And no. What is the, okay, what is my IP? Come on, that way. It should show me the IP address. So here, it is going to give me my IP address. I'm going to grab that IP address, go to the security groups, and make sure that I am able to connect to my IP address like that. And that is my source, where I can come in to connect to the port number 22 when I save. That is the most important thing you need to do to make it work for your setup. If you don't have that entry, you will not succeed in the exercises. That's one thing you want to check. Second thing you want to check is open port number 80, because we'll be running some web servers there. So port number 0 is open to the world. Port number 443 is also open to the world. Those two ports are open. That's what we are really talking about here. Is you want to set up proper security settings for port number 22, 80, and 443 in your default VPC. That's what we just made sure. Now, having done that, you want to set up a key pair, which you have already, and you want to make sure that you are providing that public-private key pair to the Amazon cloud, like right here. Go to your key pairs in the EC2 section, like here, EC2, and you will find that I have given my key pair there already. So the key pairs are already, the workstation key is there already. This is what you want to make sure, that you have your key pair already with the Amazon cloud in question. I am dealing with Northern California. You may be different, but just stick to one area, one cloud, and that's where you give your public key to them. You use that private key, and then you want to do next thing is to get your AWS credentials. What we want to do is cut down on the work of actually manually creating a machine like right here. Sorry, not right here, but in the EC2 dashboard, you create a launch an instance, and you select, and then you configure all of these manual steps. I want to cut all that and automate this. We get into that point, and that automation can happen, but you need to know your credentials and have them in your knife RB. You need to save those things here. Because once you have them saved in this knife RB configuration, then you can ask Chef, hey, you go create a machine for me. I'm not going to go to the Amazon console. That's boring. Like, I'm not doing this work. You do it for me. You create a machine in EC2. You run, set up this, set up that, boom, everything. Do the whole thing for me. I am not launching an instance for you this time. I did it twice already in the previous exercises. I'm done with it. I'm not going to go here and click this button that is for people. I want to automate. I am a nerd, right? Different from people. So don't do this thing by hand. Not doing it. So I need to get my credentials. You know how to get credentials, right? You go to Northern California, rather, in your name here, and then you go to billing security credentials. That's where you find your creds. And so you go to the security credentials section, access key, and all of my keys are deleted already, which is good. Now I need to create a new access key, and I will see them, and I copy them, and then I grab them and close the file, and then put them right here in the knife RB, somewhere here. So this is where I'm just dumping it right now, like this, but that's not how you write it. We'll get to it as to how do you actually use it. So we'll define it as to how do you actually write them. But I have my keys in good shape. I have saved them, and I'm going to use that. How do you use them? So you want to actually create your knife RB like this. Like, you want to provide your knife AWS access key ID and your AWS access secret secret key, and the region of choice. These three things is how you write your knife RB. So what I'm going to do is give you a comprehensive view in a completely written knife RB as an example. So this is a knife RB example that I have written for you. And let's go copy the whole thing like that. Bring it here into the actual knife RB that you have right here. And at the bottom, paste it. So now I would like the knife RB to look like this, but it looks like what I have currently on the top. So I'll go compare line by line and match what I think it should be versus what the template says it should be, and understand what is different. At the very top, I have this line, which is a comment. So I'm going to get rid of it. Then I have this line number 1. It matches line number 19. That is good. So I can get rid of 19. Then I have line number 2 matching line number 19. Good. Kill it. 19 matches number 3. So kill it. This 19 matches number 4. Kill it. This 19 matches number what? 5. Kill it. Then we have this matching number 6. Kill it. Now this one doesn't match. The reason is it is different. So I want to keep this and actually delete the one that I have on line 7. So I copy this from here, move it right there, and you will see the difference is site cookbooks first, and then the other called cookbooks. So I'm getting rid of that line and keeping the one that I wanted to keep, because this area is where I will keep my site cookbooks. The folder doesn't exist yet, but it's a good idea to keep it. I'll create that folder for us right here. Right click, new folder, site cookbooks, and then save. To create a folder, it is empty right now, which is fine, but the folder is going to get priority precedence over the other folder, which is just cookbooks. And that's what we did. Line number 7 is different. Then I have this line number 20, 21, and 22. Let's go grab that. Cut. Put it right there. Save. And I notice that the way to write your access key ID is not like this, but in the change this section. I'm going to go change this section and paste it right there. Similarly, you don't write your secret access key like that, but instead you copy this from here or cut and you paste it right in that location. Paste. That's how you actually write your secrets for AWS in a knife configuration. And that's what we just did. This is based on an example I copied from my website, but actually the real source for this is not my website. It is the the GitHub location for the source code. We'll go there right now. But one more thing before I go there is this region that I'm dealing with is not US West 2, it is US West 1. So save it. In my case, it is US West 1 because I'm dealing with what cloud was that? Northern California cloud. So console, AWS, Amazon.com, that cloud in the Northern California region, which is what I chose. I have US West 1 as the acronym. If you don't know how to find it, you can just Google search for it. So say Northern California AWS region code. And it will tell you. It should tell you somewhere in the documentation. Like maybe this documentation should be the right one. It should show us endpoint for a US West. They're not easy to find. But yeah, maybe the third link. It's a nightmare to find these things sometimes, but here it is. Yeah. So US West 1 is the right answer. Where is West? Right here. US West 1 is Northern California. That's how you can find out the right phrase to type here, US West 1. Okay, having done this part, there are some other lines here. For example, other clouds. You can see how you write secret credentials for other clouds. For example, here the rack space detail. Change this and change this. Here is the DigitalOcean detail. Change that. And like that, you have multiple clouds. You can just add configuration for other clouds. But then how do you find these things? And what if you're using your own internal cloud called OpenStack? You have a company internal cloud. What if you want to use that? You will use pretty much the same idea you have here. And instead of rack space, I think it is pretty similar to rack space is what OpenStack is. So you will do something like this. Hold on, let me just change it. But again, I don't want to make stuff up. I will go to the source code and find it for us. So we will go, it should be something like this. We'll find out exactly what it should be. But Rackspace is an OpenStack based cloud. So it is pretty similar to what you will have in your company. You need to change this and change that by asking your OpenStack administrator inside your company. And that's how it will look like. But again, I just made these things up myself. Bad idea. Let's go to the source code and find out how do you find this thing. So what I'm really trying to tell you is we will use the knife command, and we used this in the past to prepare and cook. Or rather, in other words, bootstrap. That's what we did. Bootstrap, yeah, some spelling. So that's what we did. What I want to do now is, instead of these steps, how to create a server and then bootstrap it. And then, the create server action using knife, which should actually go to the cloud of whatever cloud you like and create a server and then install Chef and then run Chef and then make the desire complete, right? I think my microphone is not in the right spot, so I will bring it back. I forgot about the microphone. So bringing it back. So what I'm doing is I'm modifying and expanding the scope of Chef, not just the prepare and cook and bootstrap, but create the machine for me and then bootstrap it and then do his thing and make the desire succeed, make my desire complete. For this to function correctly, for create action, create a server, somebody has to go to this location and click these buttons, which is not what I want. So you can go to EC2 console and launch a machine like that, but I'm not doing it. So there needs to be a tool that will allow Chef to interface with the Amazon cloud. This interface will require a key control from Amazon's. We got the key pair. We got that already put into the knife RB. But then there is another thing that is needed to let knife be aware of the fact that we are going to use the Amazon cloud. That piece of software is necessary. Just adding a key pair is not enough. Similarly, you want to have this knife tool operate on the Azure cloud. That's also possible. You just need to grab some credential from here and provide that in the knife RB configuration file and also add some software. Same thing again. Knife RB, you want to operate that on the DigitalOcean cloud? No problem. Get a token from here and put the token in the knife RB file. But then you have to add some software. What is that software here and here and here? What software are we talking about? That software is called a knife plugin for Cloud X. You name your cloud. There is a plugin for that available already. Let's go see some of them. We'll go to GitHub. And there we will search for the Chef organization. The Chef organization. In there, in the Chef organization, we'll search for projects and see what do we have. And we'll search for knife. What do we get? We got the plugin for knife EC2. That was updated a day ago. So people are building it. This plugin is called Knife EC2. It's a plugin, which means It is a collection of Ruby code, which means it's a Ruby gem, which means it is right here in the Ruby gems website. Knife EC2 is a plugin. It's right here, and it was updated recently, a few days ago. And you can get this version of that plugin downloaded from this. You can put it in the gem file if you like and install with the bundle update. All these methods are available. And so that is a plugin that we will be using. Similarly, there is a plugin for Rackspace Cloud. There's a plugin for OpenStack Cloud. Let's go see what OpenStack plugin does. This plugin tells you exactly how to use this Chef tooling with OpenStack. And you need to install your configuration knife RB like that. That's what you need to grab and put that in your knife RB pretty much like here. So you need to provide your company, say Boeing.com or whatever that name is. I don't know what will be IDK, but some location internal, Boeing.com, your OpenStack dashboard username. This will be provided to you by your OpenStack administrator in your company. This will be your password. This will be your tenant name, and this will be your region, which could be Bellevue or I don't know what. I have no idea what you have, these names, but your admin will tell you. And you will grab those settings and put them in the right location in lines number 22, 23, all the way 26 in the knife RB configuration. And you can create a new machine in your internal private OpenStack cloud in your company using the same method that we are going to do right now in Amazon. I have these credentials already, so I'll use them. You need to get your OpenStack credentials and put them, and that will function just fine. But I would suggest that you actually do these exercises in your own private OpenStack cloud. You should do these exercises in your internal cloud, not with public cloud. But I don't have access to it, so I'll show you examples of various other clouds. In fact, we'll show you 3 clouds, the same exact exercise, 3 different clouds. They're written down, by the way. The steps are written down black and white. I don't know what your OpenStack login is, but that's not material. You should be able to find it internally. Talk to your admin. They'll give you and these details, and you connect and you actually tell them what you're going to do and run these exercises in your own private cloud, in your internal company setup, and you should succeed. If you get stuck, I will be able to help you. Yes, I will not know what you're dealing with, but I'll still be able to help you. Because I deal with Chef. I have no problem. I will be able to, if you give me the logs, I'll tell you what is failing and how do you fix it. I can walk you through that part, no problem. I have no problem doing that. If you're interested, please go ahead and do it. Is to actually apply this in the context of your company. So, cutting this out, that's the focus you want to go and take in a real life application in your company inside. Do that. But you can leave this. You don't need to delete this segment. I'm going to leave it right here in my folder, in the knife RB, although I'm not going to use it. So I'm leaving this section as is. Similarly, go back here in the other clouds. Back here, we have a plugin for Azure, the Microsoft's cloud. It was updated 23 days ago. You can see what it takes to incorporate working with the Azure cloud. Yes, the same way. And yes, there are exercises, steps written down for you as to how do you interface with the Microsoft Azure cloud also, using the same workstation that we are dealing with. And the thing that will be necessary for this to function will be to have a knife Azure gem included. Okay, next. There is a Google Cloud plugin. So you can use Knife Google, Knife Linode, and there are a bunch of other knife plugins. You can keep going. And there is a knife for KVM. KVM is a hypervisor. There is Knife Analytics, Knife ECS for Alibaba Cloud, and a bunch of others. But again, this is not an exhaustive list. The way to actually search other gems is go straight, not just to the organization called Chef, but go straight to GitHub. And there you search for knife plugins. For example, Knife DigitalOcean. is another plugin available. So you can find it right there. This plugin is available. And like that, you will find that these gems are available for us to use. And that DigitalOcean token, if you put that token right there, then you can use the DigitalOcean cloud and have Knife create a server in the DO cloud and do the whole thing. Same thing. So that's what you do in your Knife RB. This is like the most critical thing to understand. By the way, Knife RB is where you store your credentials, which means you need to protect this file like crazy because your keys are right there. You don't want to be leaving these keys out in the wild. If you somehow manage, let me tell you and let me caution you, if you somehow manage to leave these keys out in the wild, you will, I guarantee, you will get hit with a bill. And it's not about hacking, it's going to be a bill to you, a bill that accumulates at the rate of $500 to $600 per hour. It accumulates the charge. That's how your account will be taken over by hackers. And I guarantee this, in 10 minutes, you let these keys go out, within 10 minutes, somebody will grab those keys and start cryptojacking on your account, on your wallet, using your account, and you will be responsible for a bill. And therefore, don't mess with it. Do not let go. Again, repeating this, do not let go of these credentials out in the wild. I would like to repeat that one last time. Please do not let these credentials go public. Don't share them. Don't give it to anybody. It's a bad idea. You will get hit with a bill. And yes, you will have to call Amazon with me and we'll have to explain to them what's going on. And it takes a lot of effort. It's a bad idea to share keys. So don't do it. Okay, enough. Moving on. But I'm being particularly cautious because in the past, things have happened where people have accidentally shared their keys and they got hit. I'm not kidding. This thing is called cryptojacking. If you haven't heard about it, read it. Cryptojacking. So that what happens in cryptojacking is basically people take over control of your cloud, for example, here. And in each of these regions, like you have Virginia, Ohio, and everywhere, they will start the maximum possible number of machines, the biggest possible size allowed in your account, and start Bitcoin mining. That's what cryptojacking is. They'll just start machines and start cryptography software to mine Bitcoin. And you will get hit with a bill that is responsible, that you will be responsible for in each of these locations, Virginia, Ohio, California, all of these places. And they will exploit to the maximum number of machines, maximum size of machines in every single region in Amazon and just any cloud. And then you pay for it, they make money. That's cryptojacking. That's what will happen. And I can virtually guarantee within 10 minutes, try that. I mean, don't try that. Don't try that. Don't do that. It's not fun. Not fun. So back here.
Delish.
Yes.
Quick question. I mean, doesn't Amazon or any of these other cloud providers have some type of safety, gate where if you're not a company or if you just have a basic user account, any of the cloud platforms, that it doesn't start up more than 100 machines or whatnot? Yeah,
I think the initial account limits are in every region. You have 20.
20, okay.
Yeah, I think in every location, 20 here, like that. That's the original limit. It may have changed, but the last time I saw this issue, the thing I noticed when the person who was a bootcamp student in the bootcamp, poor guy, what he did was he pushed out his Git repository. Sorry. He pushed his Git repository and he forgot to ignore the knife RB like this, like I forgot, and like this. You should ignore that file. And now that file is not going to be a part of your Git commits. And he skipped that step. And then he Git add, git commit the whole thing, and this knife RV showed up on GitHub because he pushed. Bad idea. Within 10 minutes, he got cryptojacked. He called me. What we saw was pretty much in every single region, 20 machines of the biggest possible size. Like here, you go to the biggest size was, I think in my account, I have even bigger machines. He was probably limited. The GPU optimized G2X extra large, that's the machine. I think maybe not. Maybe he was slightly lower machines. So maybe this, I don't remember which machine. But these capabilities are limited to new accounts. You can probably not get the biggest possible machine that is available, and you will get only so many of them. So that's what I saw is big machines, 20 of them in each region running something. We could not even enter the machines because the hackers used their own private key. So we could not even get inside. But what we saw was that in the account, in the billing section, a bill alert already popped up, and somebody from Amazon called them. By the way, my bill is kind of low because all I use is buckets and not much. So you can see my S3 storage is 33 cents and my CloudFront is 20 cents. That's pretty much my very minimalistic usage of Amazon Cloud. I mostly use the Google Cloud, but that's me. So bottom line is, yes, there are limits that Amazon puts, actually every company puts, that you can consume based on a new user. But over time, they will add capabilities if you ask them. That is something that you need to worry about, is to not share your secrets. Otherwise, cryptojacking is real. It does happen, and it will happen to you if you make a mistake, like sharing this detail, like write this detail, like this one. You don't want to be sharing that detail and this detail with people. And by the way, I just shared it with you and my recordings go public. So I will have to go and destroy the secret. I will do that at 7 o'clock today. And so what I want to do now is just understand that these tools that we are using will need to include a collection of gems that we want to interoperate with, right? So let me close out these Amazon windows and stick to this knife RV for accuracy. We saw that. Let's go further, proceed. And what I want to do is to create a gem file where I will incorporate certain gems. For example, I would like to use the EC2 gem, the DigitalOcean gem, and these gems will help me interface with these two clouds. And later on, we'll add another gem, like Azure gem, knife Azure. We'll add that also. But for right now, this is the gem file that I'm dealing with. So in my gem file, I will write these things, copy them, bring it here, and then create a new file. Call it gem file, save it with this content. And the folder will be the chef repo folder, the one we are dealing with. And the file will be called gem file. And then I save it. So that new file is my gem file. Now I need to bundle. Bundling will install these gems for me. And you see that my versions are slightly different from the previous time. It's up to us to what versions we want to use. I'm just giving you an illustration of a variety, not necessary that I need to use this version, but I'm just using this version. With that said, these are also tested. That means it works. I have tested this myself multiple times. And so if you vary from this version, something might disturb the balance and something may not work. If that happens, ping me, I'll fix it. So with that gem file in place, it is going to give us the ability to interface with EC2 cloud, Amazon cloud, and the DigitalOcean cloud. So two clouds. Closing it. Now I will bundle update. And what this bundling action will do is install those two gems. They are written down in our gem file right here. This file will go now bundle, and bundle will bundle these gems for us and finish off the availability of these two gems that I need for the action to create a server using Chef. So it is going to do that for us. The 5 gems are installed. It actually installed 131 gems that are dependent gems. So now we have them all. We'll now proceed further, which is to go to the next step. In the next step, what I want to now do is test whether I can interface with the Amazon cloud because I put my credentials there, right? So here I can say bundle exec, which is a prefix as a required prefix that you know already. And so then I say knife. Can you go to the EC2 and give me a list of all the servers I have running there? can you go to the EC2 cloud and give me a list of servers that are running right now? And what do I expect? I expect a list of 0 servers because nothing is running. And so let's hit it. So I hit, and it's going to tell me a list of 0 servers right there. I have nothing running. It tells me right there. You have an instance ID, name, public IP, private IP, flavor, this, that, nothing running. Expected, because I have nothing running there. Right? That's what I did. So this tells me that my Amazon cloud is properly connected with my setup because my credentials are there in the good spot. Now, the server listing action, which I did it through knife command. So it was able to interface with the cloud and get me the list of servers running. Now, don't confuse this command with anything in any region. It is limited to the region you selected. So which means Northern California for me. It could be different for you. But it is giving me a list of all the EC2 machines running in the Northern California cloud. There are 0 instances. And therefore, I get a 0 answer right here. No servers running. Now, with that action understood, what I would like to go is further see what cookbooks do I have in my chef server. So in the local machine, I have these cookbooks. But in the chef server, what do I have? Let's see. It goes and connects to the chef server for my chef server and gives me that I have these cookbooks. Why are these so many cookbooks? They are there because of a last exercise I did some time ago. So I need to get rid of all these books. I can very easily get rid of them. How do you get rid of them? You use a cheat sheet, like right there. The cheat sheet is available right there. I'll go and read the cheat sheet, and this cheat sheet is basically a list of bunch of things that I've dumped there, just for me to quickly cheat. And here it is, bulk delete old cookbooks from the chef server. So I'll grab that command, run it here, and say, delete all the books, go away. So I'm going to clean up my chef server and make room for new stuff. So it is deleting all the books that I may have in the past. And that is my cheat sheet. So this cheat sheet is available in this location. And I'm going to give you a link in Slack chat, but going back to our exercise. What you will see is if you don't have your credentials in good shape, you will run into this kind of a failure. Authorization failure. If your keys are invalid in knife RB, this command of EC2 server list will fail on you because your authentication credentials are broken. That is expected. Next, what I want to now do is, now that I have my connection between my computer, my laptop, and the Amazon cloud correctly connected, and my connection between my workstation and my chef server correctly functioning, because I see that, like right here, I'm able to delete all my books. And then I'm able to list all my books, and I see that I have no books there. List is empty now. So it is properly connected. You can see this also visually. If you go to Amazon, go to the chef server, manage.chef.io, you can also see the visually that this particular chef server in the policy section, in the cookbook section, showing all the books, it is showing me empty because I deleted all the books. That's expected. So no books, no show. Next. Back here. At this point, since we have done a lot of grunt work, a lot of copy and pasting from this and that, knife RB and this credential and that credential, it's a good idea to take a snapshot of the machine. Like this workstation, you have these things right here. The .chef folder contains a knife RB with your credentials and all the things that you have copied and pasted. And this lot of work, like a lot of boring work, one time boring work is now done. So we want to now capture a snapshot. You know how to capture a snapshot already. You go to the workstation. Where is that? Oh, hold on. Let me see. Yeah, go to the workstation, VirtualBox machine, take a snapshot. That way, you are able to preserve a snapshot, call it chef is ready or something like that, and just save. That way you can always go back to this point in time anytime you need to. If you make a mistake going forward, you make something doesn't work, you can go back and go to this point in time. So now you know at this point in time your connection to Amazon is working, your connection to Chef server is working, and you can actually proceed to using Chef with the Chef server. With that, let's use it now. So I am going to go 50-50 right now. 50% on this side with the workstation, and then 50% on the browser outside. The Chef is ready. Snapshot is ready. We'll go next. Now I want to send my kitchen to the Chef server. Right? I told you about this already in the last, before break. You have to send all the things that you have to the Chef server. So the Chef server knows what you're dealing with. You're telling your desired state. So we'll begin with that. We want to make sure that we are uploading all the books we have. Like all the books. How many books we have? We have one. What books do we have? This book called Starter. That book, I want to send it to the Chef server. How do I send it? You basically upload it. What do you need to do? You say bundle exec, knife, cookbook, upload all the books I have from this location. So you send it. The book goes. The only book we have. It goes to the Chef server. So it uploaded all the books. Now you have that book available in the Chef server, and you can list it. And you can see the list containing one book right there. You can also see it visually right here, and refresh the page to see the book called Starter, and it showed up. Next, we want to now send our role that we have. We have a role in there in this folder, right? This role called Starter role. We want to send that role. This role knows your name, like right here, because that's a ready-made role for you, because you customized it to the Chef server, created a custom download for you. It has your key, it has your name and all that. But it knows about you. So that role needs to be sent to the Chef server. And something is unique to understand here is that, you know, the Chef server itself gave you this folder called Chef repo. And it gave you this whole thing as download. And now you have the cookbook, and then you have the roles folder and all that. But why are you then again uploading it? Didn't it give it to you to begin with? That's a good question people ask. Yes, Chef server gave you this download, but then Chef server has no idea what you have in mind for the desire. So it doesn't assume anything. You have to express your desire by explicitly uploading your cookbooks, your roles, your whatever, and data bags and this and that to the Chef server. It is not going to go to the same location which gave you this download, but it will go to the appropriate location where it is supposed to be storing the cookbooks and data bags and environments and other things. That's what you will see. It will go to the right location, not where you downloaded the Chef starter kit from. So we will now, first of all, look at our roles, and we have these 3 roles in there. You can also use the browser to delete a role. For example, I just deleted one. And there are 2 more roles. I'm going to delete that role in the web browser. And there is a bug in Chef server that you have to actually refresh the page every time you change something. It doesn't automatically refresh. So that's the issue that I have with this Chef server. It doesn't automatically refresh itself. You see, I'm deleting a bunch of things because these are old things that I want to get rid of. And I want to now send my role. The current role I have is empty. So now I want to send this role that I have, which is called the starter role. And what it does is send you a log entry that says, welcome to Chef, comma, your name. That's what this role will do for us. So I want to send that role. Now, sending a role to Chef server can be a little clumsy. It is like this: bundle exec knife role from file, and then the roles folder where you have the roles stored, and then the file name. I think it is clumsy, but that's how you get, that's what you get. So that's what you need to remember, or just use the cheat sheet. That's the command which will actually take the role from file, knife role from file, and then roles, folder, and then the file. Now we have sent the role to the chef server. So you should see the role in there. Once you refresh, you should see the role pop up right there called starter. And we'll proceed further. What I want to do next is now check how many roles we got. So we'll go check the roles we have. Oops. Okay, go upload the book again. So it's not going to upload the book again, but just check the version that they have in the chef server and just not do anything, which is what it did. So now I want to check the roles that we have: bundle, exec, knife, role, list. It will give me one item called starter. And there, next. What I want to do now is is to manage everything programmatically step by step. We'll grow into complexity as we go along, but I want to create a machine programmatically. So we'll open up this segment, go to an editor here, and look at what it has. And let's see what it does for us. So let's go understand what it does. What it's going to do is bundle exec, which is a prefix, you know that already. Then knife EC2 server create. Go to the EC2 cloud, create a server. And while doing that, use my private key right there. This private key that I have labeled is IDRSA. I am using a different name apparently here in the Amazon cloud. I am using a name which is, what is it? In the Amazon cloud EC2 dashboard, my key pair is called workstation. So I need to use that name instead of this IDRSA name here. It is called workstation. That's the name Amazon knows it by. So this name is the name that Amazon calls it. This is the file name that I have in my local workstation. Amazon calls it workstation, as you saw in the example here. Key pair name is workstation. So I'll use that key pair name right there, line number 10. Next is line number 11, which is a reference to the actual private key. And that private key is sitting in my workstation, is by that name. I intend to create an Ubuntu workstation, an Ubuntu machine in the Amazon cloud here, and launch instance. I want to create an Ubuntu Linux. So I will say this one. And then I know that the username for that machine in Amazon cloud is Ubuntu. So line number 12 matches that. Next one is something to understand where it comes from. It is the machine image, the just enough operating system image, the AMI, Amazon machine image. And then there's some random number here. That random number is actually not random. It is provided to us by Ubuntu. Where do they give it to us? You can get it in multiple ways. One of the places to find that number, the Amazon machine image number, is first of all to remember to understand that it depends on the region you are in. So a machine image in here will be different from the machine image in, say, Northern California. The machine image number will be different for different clouds. And in this example, let's go see if you try to select the Amazon Northern California location and look at the Ubuntu server, you will find that it actually tells you the AMI right there. So you can grab it like from here, Ubuntu server, blah, 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 AMI. You can grab it from right there and put it in this place. Oops, this place. That's one way to do it, but this is not the right way. I mean, this is also right. It's not wrong, but I prefer another way. The way I prefer is the way to ask the source. Like, who is the source of this operating system? It is not Amazon. Are you kidding me? It is not Amazon. So who is the source? It is Ubuntu, right? So I'd rather ask them, what do you have for the image for Amazon in Northern California for me? That's the question I want to ask them. I want to find out, what do you have as the AMI ID for me in Northern California for Amazon Cloud? So I'll say, Ubuntu, help me find an AMI. I'll run a search, Ubuntu AMI Finder, and I get this tool. In that tool, I find it that they've given me a list of AMI available across the Amazon cloud. And I see that there are, how many entries? 424 entries. Okay. So now let's narrow it down. It's too big, right? I want just one. I want one number. So I will narrow it down, first of all, by limiting myself to the cloud in question. I am in US West 1. So I now limit myself to 34 entries. Still a big number, right? So I'll further narrow it down to the operating system of choice. So my operating system of choice, I don't know what these things are, so I have no idea. So I'll skip that. Although actually I know, but I'm going to skip it because it's not obvious to me. So I don't know what to pick. So I'll skip. Now here, this version. What do I select? I see 1704, looks like a recent operating system. Maybe I select that. But then for production, I find that, there's a newer version. Maybe I select that one, but not really. I would stick to LTS for production support, long-term support versions. LTS versions are better than the other versions. Better in the sense that they are supported for a longer duration of time. What does that mean? Let's go see. LTS. What does it mean? It doesn't mean whatever this thing is, but it means Ubuntu LTS. So Ubuntu LTS has a specific meaning to it. And that meaning is, come on, show it to me. Hello, Ubuntu. Okay, there it comes. So LTS means long-term support. And they have a plan to release a new update for Ubuntu desktop and server every 6 months. That is too frequent. So what they have done is they release an LTS version every 2 years, which is provided as support for 5-year period. The release plan cycle is that, let's go see whether this page will find us the exact link I'm looking for. And here it is. So now if you look at this picture, it'll tell you the red lines here. The red are the long lines, where these red ones are actually mapping to an LTS release. You can see that the flags on the left side are LTS flags, 10, 12, 14, 16. Those were long-term supported versions. They carry support for 5 years. Whereas the other versions like 1710 doesn't. It's a very short-term supported version, like a couple of six months probably. Same as with 1810, 1904, 1910. They're not long-term supported. The next long-term supported version will be 1804, coming up in April 2018. It's pretty short. Very soon it will be available. It is not available right now. That date, as you can see, April 2018 will be a new long-term support. 1804 LTS is going to become available. Let's go see when it's going to become available. So Ubuntu LTS 18, when is the release? The release date is, I think it's April, but I don't know exactly now which date. The date is 19th of April, final release. That's the date in which 1804 will become available as a long-term supported option. That may be a good choice at that time. But right now, as of today, the available long-term support version is 1604 LTS. So stick to that, not 1710. Having said, we'll narrow it down to 1604 LTS. And now we have how many entries? 4 entries for AMI choices. We are looking at US West 1. Janial is the code name for 1604. And we go further. We're looking at 64-bit choices. This one. We still have 4 choices filtered from 424 entries. I will make it a little smaller and look at these 4 choices. There are 1, 2, 3, 4 AMI IDs available. I don't know which one to get. So I like to further narrow it down. What I will do is look at the release date. They're all released at April 5. So they're recent. I will now look at the instance type. Here I see that the instance types are instance store, which is an ephemeral disk. I am not going to recommend you to use that instance store idea. I don't like that idea. And there is another iteration of the same thing here called HVM instance store, which is another ephemeral disk. The HVM stands for hardware virtual machine, which is a good technology. You should use that, but not the instance store type. So which one do you suggest? I suggest using the hardware virtual machine, elastic block storage, SSD backed instance. So that's the type I would like you to use. So I will narrow it down, HVM EBS SSD, which is this one. Now I have exactly one AMI ID, and that is the one I like to use. This is coming straight from the horse's mouth. So I grab that copy and then go straight to my notepad and then place it right there. And you find that this number is slightly different from what Amazon is giving you, but not a problem. Both are valid. The one Amazon gives you is probably older. This one is a little bit newer and will have patches already included. So I use that. I'm going to next select T2 micro size. And I would like to say that when you create a server in the Amazon cloud using my private key in line number 11, using the public key that you know as workstation, using the username Ubuntu, you please create a machine with this AMI ID with a size of T2 micro type, the small size machine free for you, and run the role called starter as a run list. This, by the way, is a run list. You can write it like that. Or you can just use the short name called R. That's also valid. So we'll extract all this as the custom created command for us and go back to our workstation. And here we'll make it full screen. And now clear this. And first of all, bundle, exec, knife, EC2, server, list. We have no machines running there. We'll come back with a no answer, nothing answer. Now we'll execute this new command I just had for us. So paste it, and I will invoke it. And what you expect is that a new machine getting created in the Amazon cloud, and it is going to be M1 small. Although I asked for T2 micro, did I not type it properly? I think I pasted in correctly, apparently. Something is wrong because I asked for T2 micro. Did I not copy properly or what? I said T2 micro. Let's see what is in my copy buffer. It is T2 micro, but what happened to the paste? So I have the workstation key, the private key, the Ubuntu image, and the machine image. And okay, something is wrong. My copy paste did not correctly come over. Something is missing here. Okay, we'll have to do it again, which means break it and make sure that I copy paste properly. So we'll go back and make sure that I paste it here correctly. And then okay, what users saw me deleting is a little bit of funny character that was popped up in this dot character. It popped up from browser copy pasting of this ID. That happens occasionally. Sometimes you see in copying and pasting values from a web browser into a workstation terminal, these kind of spurious characters pop in. And as a consequence of that, this command ran as if it is a command only up to this point. And the last two items did not get picked up. That is a problem in copying and pasting. So remember, I saw this little dot. That should not be there. So I deleted it. Now this is a clean command. I will now take this whole command and run it again. So I'm copying it now, going to the terminal and examining right now here. What I see is now I have knife EC2 server list. Show me a list of servers I have in my Amazon cloud. I see one. That was the erroneous attempt with a bad copy paste. So let it run. I don't care about it. We'll leave it running. I'll just create another machine. This time, I know that it is waiting for me to press the enter command. It actually does not have the funny character dot after this slash, which means I'm going to invoke this command. It is going to listen to me and use the workstation key, use the private key, use the Ubuntu username, use the AMI ID that I found from Ubuntu AMI Finder, select a T2 micro machine type, not an M1 small, and apply the run list, which is take on the starter role. As a consequence, you should see that the end of this run, it says, welcome to chef, comma, Nilesh L. That's the response I'm expecting to see in a newly created machine. Install chef, run chef, and show me a log entry saying, welcome to chef, Nilesh. And let's go see that. So we'll go enter and let it run. At the end, you will see the welcome to chef entry at the end of the run. But right now you see the machine getting created. This is a second machine. This is the first one that I have accidentally created. We'll leave that one alone. We'll go to the Amazon cloud and see these things live. We'll go here and go to the AWS console, go to the Northern California location. In EC2, you will see two machines now, right there. And the one is M1 small. I think that one can be deleted. So instance state, terminate, go bye-bye, dead. This machine is what I am interested in right now, the T2 micro, which I am starting up. And that machine is actually going to be in my default VPC, the default subnet. The security groups are also default, which shows me, sorry, go back to the running instance. This T2 micro machine has a inbound rule that allows me to come in. 22 allows me, which is good. So it is going to succeed. This success actually finished the whole thing. But you will also see that it does this line, welcome to chef, comma, Nilesh. Like I said, it did exactly what I expected it to do, which is to run the starter role. Prior to that, you will see it began doing a couple of things. For example, it began, first of all, created a machine. So the machine is ready. At that time, it will wait for the machine to start the SSH daemon. And then first the machine gets created, the daemon becomes available. And once the daemon becomes available, then it creates a new client entry for that machine in the chef server, creates a new node for that machine in the chef server. Then it connects to that machine through SSH. It installs chef on that machine. Then it runs chef on that machine. Right there. It is now starting to run chef. Then when it runs the chef client on that target machine, it connects to the chef server and it grabs the starter role. So it resolves the run list. The run list is starter. So it loads the cookbook from chef server. And then it finds out that the cookbook is installed. Then it compiles it. And then it runs the recipe called starter : default, which is the starter role. And then it logs this entry, welcome to chef, comma, Nilesh. And that is the entry that you see there. And then it's report success with an instance ID and a T2 micro and all that. So now your machine is ready and running with chef and is managed by chef. So you can use it. But again, that's how you go and do. So we'll go the next time when we get together again, which is going to be on, when is that? On 20th, we will go do the more complex exercise in using chef and chef server. And that is going to be a marathon exercise. So just prepare ahead of a little bit and prepare yourself for that video that I gave you a link for. At the end of this simple exercise is the next bigger exercise, which is what I would like you to do. And I would like to remember to do one very critically important thing, which is to go to my account and delete that credential that I have here and like that and say, yes, destroy. That is a critical thing to do because without that, my key will eventually get exposed. So I don't want to expose that key pair. And I am going to stop recording right now and I'm open for questions.